देवियों और सज्जनों, हमारे चीफ गेस्ट माननीय रक्षा मंत्री श्री राजनाथ सिंह जी पधार चुके हैं। नाउ आई रिक्वेस्ट आवर ऑनरेबल चीफ ऑफ डिफेंस स्टाफ जनरल अनिल चौहान, सेक्रेटरी डिपार्टमेंट ऑफ डिफेंस R&D एंड चेयरमैन DRDO डॉक्टर समीर वी कामत, साइंटिफिक एडवाइजर टू रक्षा मंत्री डॉक्टर जी सतीश रेड्डी, डॉक्टर टेसी थॉमस DG Aero, श्री हरिबाबू श्रीवास्तव DG TM टू टेक देयर सीट्स। अब मैं डॉक्टर SV कामत, चेयरमैन DRDO से स्वागत भाषण के लिए निवेदन करता हूं। सेक्रेटरी DD R&D सर।
Honorable Raksha Mantri ji, CDS General Chauhan, Dr. Satish Reddy, Scientific Advisor to Raksha Mantri, Admiral Ghormade, VCNS, my colleagues from DRDO, and ladies and gentlemen. It is very heartening to see the response for this seminar. The topic is Indigenous development of futuristic aerospace technologies, including way forward for indigenous aero engine development. This is a very important topic, and if we have to become Atmanirbhar in this critical domain, we have to develop an indigenous aero engine. We also have to develop cutting-edge technologies which will make all our future aerospace systems world-class and also enable our systems to get exported. We have a very interesting session ahead, and I will not take much time keeping you away from these interesting talks as well as the panel discussion which is to follow. So again, let me welcome all of you to this seminar, and my best wishes to have a very enjoyable seminar. Thank you.
देवियों और सज्जनों, हमारे कार्य के दौरान DRDO ने कई माइलस्टोन प्राप्त किए हैं। इन माइलस्टोन्स को स्मरणीय बनाने के लिए हमने कई गतिविधियां प्लान की हैं। सिस्टम्स की हैंडिंग ओवर, डॉक्यूमेंट्स का विमोचन और वेब पोर्टल की लॉन्चिंग। सबसे पहले TDF ने स्मार्ट मशीन्स एंड स्ट्रक्चर्स हैदराबाद के साथ मिलकर देश में ही MiG-29 के एयरक्राफ्ट के लिए हेल्थ एंड यूसेज मॉनिटरिंग सिस्टम विकसित किया है। यह सॉल्यूशन मशीन लर्निंग और डेटा एनालिटिक्स का उपयोग करके फ्लाइट डेटा रिकॉर्डर से लिए हुए डेटा को एनालाइज करके एयरक्राफ्ट की समस्या का पूर्वानुमान लगाता है। अब मैं वाइस चीफ ऑफ नेवल स्टाफ वाइस एडमिरल SN घोरमडे PVSM, AVSM, NM, ADC से इस सॉफ्टवेयर को स्वीकार करने का आग्रह करता हूं। मैं ACNS AM रियर एडमिरल दीपक बंसल, कैप्टन विनयागम, कमांडर गिरिराज जोशी, इंडस्ट्री रैप मिस्टर श्रीनिवास अल्यूरी, श्री SN गिरी फ्रॉम सेमिलाक, श्रीमती निधि बंसल डायरेक्टर TDF और श्री अर्जुन कुमार को भी डायस पर आने का अनुरोध करता हूं। रक्षा मंत्री जी की उपस्थिति में ये सिस्टम दिया जा रहा है। देवी और सज्जनों, TDF टेक्नोलॉजी डेवलपमेंट फंड इनोवेटिव रिसर्च फंड करता है, जैसी कि अब हमारी सरकार की नीति है। अगला है सिस्टम फॉर एडवांस मैन्युफैक्चरिंग असेसमेंट एंड रेटिंग समर। रक्षा उत्पादन उपक्रम में परिपक्वता की माप का एक बेंचमार्क है। यह सर्टिफिकेट गुणवत्ता आश्वासन प्रक्रियाओं के मैच्योरिटी असेसमेंट मॉडल पर आधारित है तथा सभी रक्षा उत्पादन उपक्रम के लिए उपयुक्त है, जैसे कुटीर, लघु, मध्यम तथा बड़े उपक्रम। अब रक्षा मंत्री श्री राजनाथ सिंह जी इस वेब पोर्टल को लॉन्च करेंगे। मैं DGPCSI डॉक्टर चंद्रिका कौशिक, डायरेक्टर DQRS रियर एडमिरल रंजीत सिंह एंड हिज टीम, डॉक्टर रवि पी सिंह सेक्रेटरी जनरल QCI एंड हिज टीम को भी डायस पर आने का अनुरोध करता हूं। मैं आदरणीय रक्षा मंत्री जी का धन्यवाद करता हूं कि उन्होंने समर को लॉन्च किया। इसको आप वेबसाइट पर भी देख सकते हैं, samar.gov.in। एरोनॉटिक्स रिसर्च एंड डेवलपमेंट बोर्ड AR&DB के मैगजीन पुष्पक का विमोचन। AR&DB अपने ग्रांट्स इन एड योजना के अंतर्गत अनुसंधान के लिए प्रोजेक्ट्स को फंड देती है। यहाँ पर यह सूचित करना अनुपयुक्त नहीं होगा कि तेजस विमान की पहली फिजिबिलिटी रिपोर्ट AR&DB के अनुसंधान योजना के अंतर्गत ही तैयार की गई थी। AR&DB के सहायता अनुदान द्वारा उन्नत रिसर्च प्रोजेक्ट से DRDO, ISRO, CSIR और एरोनॉटिक्स के क्षेत्र में अन्य संस्थान लाभान्वित हुए हैं। हर वर्ष इन रिसर्च प्रोजेक्ट्स की उपलब्धियां और नतीजे AR&DB के मैगजीन पुष्पक में प्रकाशित किए जाते हैं। मैगजीन का नवीनतम अंक विमोचन के लिए प्रस्तुत है। इसके लिए मंच पर आएंगे AR&DB के डॉक्टर SK पांडे, ग्रुप कैप्टन अनूप बहल, श्री विकास राणा और मैं स्वयं सेक्रेटरी AR&DB डॉक्टर नरेंद्र कुमार आर्या। मैं फिर मंत्री जी का धन्यवाद करता हूं। इसके बाद कतार में है DRDO मोनोग्राफ का विमोचन, जिसका शीर्षक नॉन डिस्ट्रक्टिव इवैल्यूएशन ऑफ सॉलिड रॉकेट्स एंड मिसाइल सिस्टम्स है। इसके लेखक श्री के विश्वनाथन, फॉर्मर डेप्यूटी डायरेक्टर SDSC शार ISRO तथा श्री PV सूर्य नारायण, फॉर्मर डेप्यूटी जनरल मैनेजर SPROB SDSC शार ISRO है। ये मोनोग्राफ व्यवहारिक पहलू पर जोर देता है तथा ये शॉप फ्लोर इंजीनियर्स और साइंटिस्ट के लिए व्यवहारिक पुस्तक की तरह कार्य करेगा। मेरा अनुरोध है डायरेक्टर डेसीडॉक श्री के नागेश्वर राव, श्री के विश्वनाथन और श्री PV सूर्य नारायण की वे मंच पर आए। आदरणीय मंत्री जी से निवेदन है कि विमोचन करें। CVRD ने एयरक्राफ्ट माउंटेड एक्सेसरी बॉक्स के लिए हाई प्रेसिशन बियरिंग्स विकसित किया है। आदरणीय मंत्री जी का एक बार फिर धन्यवाद। CVRD ने एयरक्राफ्ट माउंटेड एक्सेसरी गियर बॉक्स AMAGB के लिए हाई प्रेसिशन बियरिंग्स विकसित किया है जो फ्लाइट सर्टिफाइड है तथा इसे सेमिलाक ने भी LCA तेजस के AMAGBS के निर्माण के लिए सर्टिफाई किया है। अब सी सेमिलाक श्री APVS प्रसाद, सेमिलाक सर्टिफिकेट ऑफ प्रोडक्शन क्लियरेंस, डायरेक्टर CVRD श्री बालामुरुगन को माननीय रक्षा मंत्री जी के उपस्थिति में प्रदान करेंगे। मेरा अनुरोध है डॉक्टर शैलेंद्र V गडे, DGS, डॉक्टर गिरीश देवधर एंड टीम, C सेमिलाक एंड टीम, डायरेक्टर CVRD एंड टीम, रिप्रेजेंटेटिव ऑफ मैसर्स ऑस्टिन इंजीनियरिंग कंपनी गुजरात मंच पर आए। आदरणीय मंत्री जी का एक बार फिर धन्यवाद। अब मैं अनुरोध करता हूं अपने कलीग कर्नल पिल्लई से कि वो ट्रांसफ़र ऑफ टेक्नोलॉजी डॉक्यूमेंट्स प्रदान करने के लिए आगे की कार्रवाई करें।
A very good afternoon to all of you. Going ahead with the proceedings, the next is the handing over of the technology transfer documents to the industries of all the DRDO developed technologies. May I request our Honorable Raksha Mantri, Shri Rajnath Singh ji, to kindly go ahead with the proceedings of handing over the technology transfer documents. In this regard, may I request our DRDO chairman to kindly come ahead to the dais, please, sir. Our DG PC and SI and Director DSQITM kindly requested to come over to the dais. Without going ahead with the formalities, the first technology to be handed over is the multi-channel laser DEW for 10 kilowatt / 2 kilometer hard kill system developed by Chess, Hyderabad. In this regard, may I request Sri Arun T. Ramchandani, Executive Vice President and Head L&T Defense, Mumbai, to kindly come over and accept the agreement, please. The DG ECS, Director Chess and Project Director are requested to be present on the dais, please. The second technology to be handed over is active The second technology to be handed over is active electronically scanned array radar, Uttam, developed by LRD Bengaluru. So may I request Sri Sajal Prakash, Chief Executive Officer, and Sri Arun J. Sarkote, General Manager, Messrs. Hindustan Aeronautics Limited, Bengaluru, to kindly come over. Director LRD and Project Director are requested to be kindly present on the dais, please. The next technology is that of Air Defense Fire Control Radar, Atulya, developed by LRD Bengaluru, and may I request Sri Vinay Kumar Katyal, Director, Bangalore Complex, Bharat Electronics Limited, Bengaluru, to kindly come over to the dais, please. The next technology is that of Nayan Comment System. Nayan Comment System has been developed by DRDO Hyderabad and is been transferred to Bharat Electronics Limited, Hyderabad. May I request Sri K. Srinivas, General Manager, to kindly come over to the dais, please. The next technology is of Unified Mission Computer, developed by CASDIC Bengaluru. May I request Air Commodore AP Saraf, Air Officer Commanding 9 BRD Indian Air Force, to kindly come over to the stage and accept the agreement, please. Next is the software for outdoor perimeter systems, STOPS, developed by CARE Bengaluru. May I request Sri Manoj Jain, Director, R&D, Bharat Electronics Limited, Bengaluru, to kindly come over to the dais, please. Next, Land Inertial Navigation System for the land-based applications developed by RCA Hyderabad. May I request Sri KL Pidro, General Manager, Bharat Electronics Limited, Chennai, to kindly come over to the stage, please. Next is the ceramic redomes technology developed by RCA Hyderabad. It is being given to 4 industries. May I request Sri Khaja Muhammad Moinuddin Khade, Managing Director, Nimra Serglass Techniques Private Limited, Hyderabad. Okay. Next, may I request Sri Chetan Prakash Jain, CMD, Central Electronics Limited, Sahibabad, UP. Next, Sri M.V. Subramanian, Head Aerospace and Defense, Carborundum Universal Limited, Chennai. May I request you to kindly come out to the dais, please. And the 4th industry, is Bharat Dynamics Limited. May I request Commodore Siddharth Mishra of Bharat Dynamics Limited to kindly come over to the dais, please. Next, troll assembly for T-72. That's Commodore Siddharth Mishra, Bharat Dynamics Limited. Any? Next, T-72 and T-90 tanks, troll assembly, developed by R&D Engineers, Pune. May I request Sri Amit Banerjee, CMD, Messrs. BEML, Bengaluru, to kindly come over to the dais, please. Next, may I request Sri Ashley Rashkina, Joint Managing Director, Messrs. Electro-Pneumatics and Hydraulics India Private Limited, Pune. Next, may I request Sri Pankaj Shah, Chairman, Global Tech India Private Limited, Ahmedabad, to kindly accept the agreement of weapon tracking system developed by ARD, Pune. The next technology of linear thermal detector developed by CIFIS, Delhi, is being transferred to 3 industries. May I request Shri Vinay Rathi, Director, Messrs. Temsense Instruments, to kindly come over to the dais, please. Next, Shri Kunal Shah, CEO, Messrs. FireSafe Technologies, LLP, Mumbai. May I request you to kindly come over to the dais, please. Next, Shri Selvakumar Balachandran, the third industry which is taking this technology. He is the Director, Technical, Messrs. Agni Controls, Chennai. Last. The next technology is CBRN, Water Purification System Mark II, developed by DLJ Jodhpur. May I request Shri Sumit Mehra, CEO, Messrs. Sparkle Cleantech Private Limited, Navi Mumbai, to kindly come over to the dais, please. Ladies and gentlemen, thank you so much, and I hand over the proceedings.
धन्यवाद माननीय मंत्री जी। अब मैं अपने नेता प्रणेता माननीय रक्षा मंत्री श्री राजनाथ सिंह से इस सेमिनार के विषय पर अपने विचार रखने का निवेदन करता हूं।
चीफ ऑफ डिफेंस स्टाफ जनरल अनिल चौहान, सेक्रेटरी DDR&D डॉक्टर समीर वी कामत, साइंटिफिक एडवाइजर डॉक्टर जी सतीश रेड्डी, वाइस चीफ ऑफ नेवल स्टाफ वाइस एडमिरल SN गौरमडे, DG एरो T टेशी थॉमस, DG टेक्नोलॉजी मैनेजमेंट श्री हरि बाबू श्रीवास्तव, रक्षा मंत्रालय और साथ ही साथ हमारी सेनाओं के सभी सीनियर ऑफिशियल्स, लीडर्स ऑफ इंडस्ट्री फ्रॉम इंडिया एंड अब्रॉड, मेंबर्स फ्रॉम एकेडमिया, मीडिया के मेरे मित्रों, देवियों व सज्जनों, आज डिफेंस रिसर्च एंड डेवलपमेंट ऑर्गेनाइजेशन द्वारा आयोजित इस सेमिनार में आप सभी साइंटिस्ट, एकेडमिशियंस, सीनियर डिफेंस ऑफिशियल्स और बिजनेस लीडर्स के बीच उपस्थित होकर मुझे बेहद खुशी हुई है। फ्यूचरिस्टिक एरोस्पेस टेक्नोलॉजीज और इंडिजिनस एरो इंजन्स के विषय पर आयोजित हो रहा आज का यह सेमिनार गवर्नमेंट, प्राइवेट सेक्टर और एकेडमिया को एक कॉमन प्लेटफार्म प्रोवाइड करता है। इस महत्वपूर्ण आयोजन के लिए मैं DRDO और आयोजन से जुड़े सभी लोगों को अपनी तरफ से हार्दिक बधाई भी देता हूं और उन्हें मैं हार्दिक शुभकामनाएं भी देता हूं। साथियों, हमारी भारत भूमि का अनुसंधान से यानी रिसर्च से बहुत ही पुराना रिश्ता है। यहाँ के ऋषियों, मनीषियों ने भौतिक तो भौतिक, उससे ऊपर उठते हुए भौतिकता से परे तत्वों पर भी रिसर्च किया है। स्थूल ही नहीं, सूक्ष्म पर भी रिसर्च किया है और तत्व ज्ञान को भी प्राप्त करने में वह सफल रहे हैं। रिसर्च हमारे यहाँ केवल एक सामान्य प्रोसेस भर नहीं है, बल्कि मैं मानता हूँ कि यह परमात्मा तक पहुँचने का भी एक माध्यम हमारे यहाँ रहा है और इसीलिए ज्ञान और अनुसंधान को देवत्व से जोड़कर हमारे यहाँ देखा गया है। इसी के चलते हमारे यहाँ ज्ञान और बुद्धि के देवी देवता के रूप में सरस्वती और श्री गणेश जी की संकल्पना की गई है। इस प्रकार भारत ने भौतिक हो या आध्यात्मिक जो भी प्रगति की थी, उस प्रगति का मूल कारण अनुसंधान अथवा रिसर्च ही था। भारत ने अगर दुनिया को योग दिया है तो पाई भी दिया है, जीरो भी दिया है, कई थियरम्स दिया है। जिसे आप पाइथागोरस थियरम कहते हैं, वह बोधायन ऋषि ने सैकड़ों वर्ष पहले इस थियरम को ढूंढ निकाला था, उसे हम बोधायन थियरम भी कहते हैं। यह सारे सभी ज्ञान कोई एक दिन की उपज नहीं थे, सदियों सदियों की जिज्ञासाओं, प्रयोगों और अनुसंधानों की यह प्रतिफल हैं, यह सारे ज्ञान। और इसी तरह कला हो, साहित्य हो, आयुर्वेद हो, भौतिकी हो यानी फिजिक्स, इस देश ने अगर इन क्षेत्रों में लंबे समय तक योगदान दिया है तो उसके पीछे यहाँ की रिसर्च की एक लंबी परंपरा रही है। फिजिक्स का तो मैं स्टूडेंट और टीचर भी रहा हूँ, दोनों, इसलिए हमारे देश के फिजिक्स के क्षेत्र में उच्च कोटि के जो रिसर्च ट्रेडिशंस हैं उससे भी मैं अच्छी तरह अवगत हूँ। न्याय और वैशेषिक जैसे वैदिक काल के लिटरेचर में फिजिक्स के अनेक सिद्धांतों के सूत्र परिलक्षित होते हैं, जिनका आज दुनिया भर में पठन पाठन हो रहा है और उस पर विचार भी हो रहा है। स्कॉलर्स का यह कहना है, वह बताते हैं कि महाविस्फोट, जिसे बिग बैंग के रूप में इंटरप्रेट किया जा सकता है, का भी जिक्र हमें इन लिटरेचर्स में दिखाई देता है। और यह रिसर्च की सुदृढ़ और सुदीर्घ परंपरा के बिना संभव किसी भी सूरत में नहीं हो सकता है। आप में से कुछ लोग शायद न जानते हों कि जेनेवा स्थित भौतिक विज्ञान यानी फिजिक्स की दुनिया में सबसे बड़ी प्रयोगशाला, जिसे यूरोपियन ऑर्गेनाइजेशन फॉर न्यूक्लियर रिसर्च अथवा सर्न के नाम से जाना जाता है, के बाहर भगवान नटराज की एक विशाल प्रतिमा लगी है। आप सभी लोगों ने देखा होगा। यह सृष्टि के उद्भव यानी सृष्टि का जन्म जब से होता है, सृष्टि के उद्भव और विकास यानी डेवलपमेंट, उसके विकास के प्राचीन भारतीय विज्ञान और अनुसंधान के प्रति कृतज्ञता का ज्ञापित करने का एक प्रतीक है, यानी ग्रेटिट्यूड एक्सप्रेस करने का। हम अपने समाज, राष्ट्र अथवा विश्व को क्या दे सकते हैं, यह इस बात पर निर्भर करता है कि हमारी अपनी प्रगति क्या और कितनी रही है। इसलिए आज हमारा देश अपने आप को पूर्ण आत्मनिर्भर बनाने और दुनिया के कुछ सकारात्मक देने की आकांक्षा के साथ तेजी के साथ आगे बढ़ रहा है। तो इस आकांक्षा की पूर्ति के लिए सभी सेक्टर्स में हमारी अपनी प्रगति निश्चित ही अत्यंत आवश्यक स्वाभाविक रूप से हो जाती है। इस उद्देश्य से हम अपनी डिफेंस रिसर्च एंड डेवलपमेंट की प्रगति में महत्वपूर्ण प्रयास कर रहे हैं, और मैं इसका श्रेय यदि देना चाहता हूं तो आप जैसे सारे वैज्ञानिकों को देना चाहता हूं। और मुझे कहते हुए बेहद खुशी है कि डीआरडीओ इस दिशा में एक फ्लैग बियरर की भांति लगातार आगे बढ़ता चला जा रहा है। साथियों, डीआरडीओ के साइंटिस्ट, इंजीनियर्स और टेक्नीशियंस को मैं हमारे सैनिकों के ही दूसरे स्वरूप के रूप में मैं देखता हूँ। आयुध के बारे में सोचने वाले सैनिक, यानी हथियार वगैरह, आयुध का विकास, हथियारों का विकास, वेपन्स और निर्माण करने वाले सैनिक, आप सभी अवगत होंगे कि प्राचीन काल में जब युद्ध पद्धतियां बहुत विकसित नहीं थीं, प्रत्येक योद्धा अपने सभी कर्मों के लिए स्वयं जिम्मेदार होता था। उदाहरण के लिए, लड़ाई करने के मूल काम के साथ साथ उसे अपने खाने पीने की भी व्यवस्था करनी होती थी, अपने पहनने की, अपने को ढकने यानी ओढ़ने की और रहने की भी व्यवस्था उसे करनी होती थी, और साथ ही अपने अस्त्रों, शस्त्रों और साजो सामानों को भी उसे तैयार करना होता था। पर जैसा कि परिवर्तन सृष्टि का नियम है, योद्धाओं की इस अवस्था में भी बदलाव आया और युद्ध के अलावा उनके बाकी के जो काम स्पेशलाइज तरीके से स्पेशलिस्ट के द्वारा किए जाने लगे। ये सारे स्पेशलिस्ट लोग योद्धाओं के साथ साथ युद्ध के मैदान में भले न जाते हों, पर इनके बनाए अस्त्र शस्त्र योद्धाओं को मजबूती प्रदान करने लगे। इसे लाभ ये हुआ कि योद्धा अपने मूल कार्य पर फोकस करने लगे, यानी इन साइंटिस्ट के कारण ही यह संभव हो पाया, जिससे उनकी इफिशियंसी में वृद्धि हुई और आयुध के स्पेशलिस्ट अपने कार्य पर ध्यान देने लगे, जिससे उनकी भी एफिशिएंसी में वृद्धि हुई। ये स्पेशलिस्ट कोई और नहीं, ये स्पेशलिस्ट कोई और नहीं, हमारे डीआरडीओ के साइंटिस्ट हैं, हमारे डीआरडीओ के इंजीनियर्स हैं और हमारे डीआरडीओ के टेक्नीशियंस हैं, जो पर्दे के पीछे के हीरोज के रूप में दिन रात मेहनत करते हैं। आप सब पर्दे के पीछे के हीरो हैं और हमारे सैनिकों को आप मजबूती प्रदान करने वाले लोग हैं। साथियों, आज़ादी के बाद से अब तक हमारा डिफेंस एंड एरोस्पेस सेक्टर अगर लगातार मजबूत हुआ है तो डीआरडीओ की उसमें बहुत ही महत्वपूर्ण भूमिका है। अपने रिसर्चेज और इनोवेशन से डीआरडीओ ने हमारी राष्ट्रीय सुरक्षा को सुदृढ़ करने में अपना महत्वपूर्ण योगदान दिया है। एमिनिशन से लेकर गन्स, राडार सिस्टम और मिसाइल्स तक के डिज़ाइन और डेवलपमेंट के माध्यम से डीआरडीओ ने स्वयं को नेशनल सिक्योरिटी को मजबूत बनाने में सहायक सबसे स्ट्रांग पिलर में से एक साबित हुआ है। यह बड़े हर्ष और गर्व की बात है हम सभी के लिए। पिछले कुछ वर्षों में देश ने तपस और AEW&C मीडियम रेंज आर्टिलरी गन, हेलीकॉप्टर, राडार जैसे स्टेट ऑफ द आर्ट प्लेटफॉर्म और वेपन सिस्टम डेवलप किए हैं। दुनिया ने हमारी अचीवमेंट्स को नोटिस किया है और कई देश अब हमसे डिफेंस इक्विपमेंट इंपोर्ट कर रहे हैं, जबकि कई और देश इंडियन वेपन सिस्टम हासिल करने के प्रोसेस में हैं। एरोस्पेस इंडस्ट्री में LCA तेजस विमान गेम चेंजर साबित हो रहा है। साथियों, एक अत्यंत सक्षम एरियल प्लेटफॉर्म LCA तेजस का फ्लाइट सेफ्टी में एक सराहनीय रिकॉर्ड है, जो इसकी क्वालिटी के बारे में बहुत कुछ बताता है। इसकी सफलता के आधार पर सरकार ने अब इंडियन एयरफोर्स के लिए LCA Mark II को मंजूरी दे दी है, जबकि ट्विन इंजन डेक बेस्ड फाइटर भारतीय नौसेना के लिए अभी अंडर कंसिडरेशन है। हमने 5th जनरेशन के स्टील्थ एयरक्राफ्ट के रूप में एडवांस मीडियम कॉम्बैट एयरक्राफ्ट के डिजाइन और निर्माण के राह में भी अपने कदम आगे बढ़ाने प्रारंभ कर दिए हैं। कहने का अर्थ यह है कि जल हो, थल हो, नभ हो, सर्वत्र सुरक्षा व्यवस्था को मजबूत करने में डीआरडीओ सदैव फोर फ्रंट पर रहा है। इसके लिए मैं पुनः आप सबको बधाई देता हूं। और साथियों, आज भारत में एरोस्पेस सेक्टर अपने एक महत्वपूर्ण पड़ाव पर है और इसे एक नई दिशा देना आज की जरूरत है। ग्लोबल सुपर पावर बनने की और लगातार प्रगति करते भारत के पास नेक्स्ट लेवल की डिफेंस फोर्सेस का मजबूत सपोर्ट होना चाहिए, जो किसी भी नई चुनौती का सामना करने में सक्षम हो। इसलिए मेरा मानना है कि हमारे देश को आर्टिफिशियल इंटेलिजेंस, ड्रोन्स, स्टील्थ, हाइपरसोनिक और क्वांटम कंप्यूटिंग जैसी नीश टेक्नोलॉजीज का उपयोग करके आवश्यक वेपन सिस्टम के इंडिजिनस डिज़ाइन एंड डेवलपमेंट पर ध्यान केंद्रित करने की आवश्यकता है, जो कि आप लोग कर भी रहे हैं। इसी तरह इंडियन एरोस्पेस सेक्टर को नई ऊंचाइयों पर पहुंचाने के लिए भी इंडिजिनस एरो इंजन का डिज़ाइन और डेवलपमेंट भी मैं समझता हूं कि वर्तमान समय की सबसे महत्वपूर्ण यह आवश्यकता है। आज जब हम अपनी आज़ादी के 75 वर्ष पूरे कर अमृतकाल में प्रवेश कर चुके हैं, हमें इस बात पर फिर से विचार करने की ज़रूरत है। हम कब तक दूसरों के इंजन से अपनी उड़ान भरते रहेंगे? हम कब तक कहते रहेंगे कि हमारा प्रयास जारी है? क्योंकि मैं भी यही कहता हूँ, हमारा प्रयास जारी है। बार बार हम भी कहते हैं। जब इंजन का सवाल होता है, आज भी शायद किसी ने मुझसे पूछा था कहीं पर, तो मैंने कहा कि अभी इंजन का प्रयास हमारा जारी है। कभी तो हमें रिजल्ट देना ही पड़ेगा ना, ये बात तो पक्की है। यह एरो इंजन का डेवलपमेंट न हो, पानीपत का युद्ध हो गया हो, कि जो दादाजी ने रटा वही पिताजी ने और वही बच्चा भी रट रहा है कि प्रयास जारी है। हम जब स्कूल में पढ़ते थे तो 1 रुपये की जनरल नॉलेज की एक किताब आती थी। मालूम नहीं अब आती है कि नहीं, इसके बारे में मैं नहीं कह सकता हूं, लेकिन आती थी। और उसका पब्लिशर ऐसा चालाक आदमी हुआ करता था, ऐसा चालाक आदमी हुआ करता था कि आधा वर्ष बीतते बीतते वह अगले साल का एडिशन मार्केट में उतार देता था, जिससे उसकी बिक्री अधिक हो। कारण यही था। जैसे अभी फरवरी 2023 चल रहा है और कुछ ही दिन में जनरल नॉलेज 2024 की किताब हमारे सामने आ जाए, और उस किताब में होता क्या था कि पानीपत की लड़ाई कब हुई थी, सबसे बड़ा दरवाजा कौन सा है, यही सब सारी चीजें होती थी। सबसे लंबी नदी कौन सी है, आदि आदि एटसेट्रा, इन सब सारी चीजें होती थी। अब इन सब फैक्ट्स में कोई चेंज तो होना है नहीं, जो थे तो वह आज भी हैं, कल भी रहेंगे। तो क्या फ़र्क पड़ता है कि वह जनरल नॉलेज 2024 की हो या 2050 की हो। इसलिए साल दर साल वह नई नई किताबें निकालता जाता था और कमाई करता जाता था। कहना मैं ये चाहता हूँ साथियों कि हम सभी ये प्रयास करें कि एरो इंजन के लिए हमारा प्रयास भी उन्हीं फैक्ट्स की तरह न बन जाए जो कभी बदले ही ना। हमारा टारगेट ये होना चाहिए कि हम एरो इंजन का विकास कर न केवल जनरल नॉलेज की नई किताब लिखें, बल्कि अपने पुरुषार्थ से एक देश का एक नया इतिहास लिखें। और मुझे पूरा विश्वास है कि डीआरडीओ अपनी सामर्थ्य, अपने संकल्प और अपने समर्पण के बल पर इसे यथाशीघ्र करके दिखाएगा। मैं पूरी तरह से कॉन्फिडेंट हूं। और आज का यह सेमिनार इस दिशा में बहुत महत्वपूर्ण साबित होगा, ऐसा मेरा मानना है। डीआरडीओ से मैं एक बात और कहना चाहूँगा कि जो इंक्रीमेंटल इनोवेशंस हैं, माइनर सब सिस्टम्स और उनकी टेक्नोलॉजीज़ हैं, उनके डेवलपमेंट के लिए आप टेक्नोलॉजी डेवलपमेंट फंड, जिसे टीडीएफ हम कहते हैं, और आईडेक्स जैसी स्कीम्स के माध्यम से स्टार्टअप्स और नए आर&डी इस्टेब्लिशमेंट्स को सामने लाएं। आप अब डिफेंस रिसर्च एंड डेवलपमेंट के लिए अकेले सर्विस प्रोवाइडर नहीं हैं। फिर से मैं दोहराना चाहता हूं, आप अब डिफेंस आर&डी के लिए अकेले सर्विस प्रोवाइडर नहीं हैं, बल्कि अब आप इन हाउस इंडस्ट्रियल आर&डी स्टार्टअप और प्राइवेट सेक्टर लैब्स के लिए एक फैसिलिटेटर की भूमिका में आ गए हैं। अब इनकी सिनर्जी का आप लाभ उठाएं, यह मेरा आपसे आग्रह है। और आप स्वयं एक टारगेट के तहत बड़ी और डिसरप्टिव, कटिंग एज या फ्रंटियर टेक्नोलॉजीज पर काम करें, जिससे आप अधिक फोकस्ड होकर काम कर सकेंगे और आप आगे बढ़ सकेंगे। आप अपने लिए कुछ शॉर्ट टर्म, मिड टर्म और लॉन्ग टर्म गोल्स सेट करें और उसके अनुसार फुल डेडिकेशन के साथ आप आगे बढ़ें। यह इसके लिए हमारी शुभकामनाएं है आप सबको। लेकिन याद रखें कि आप वही डीआरडीओ हैं, आप वही डीआरडीओ हैं जिसने अपने इनोवेशन और प्रोडक्ट से दुनिया का ध्यान अपनी ओर आकर्षित किया है। आपकी पृथ्वी से लेकर आकाश तक अपने अग्नि के तेज को प्रदर्शित किया है, आप ही लोगों ने किया है। पृथ्वी से लेकर आकाश तक अपने अग्नि के तेज को आपने प्रदर्शित किया है। ऐसा कोई कारण नहीं कि एरो इंजन के निर्माण की दिशा में आप सफलता प्राप्त न कर सकें, ऐसा मेरा मानना है। मुझे मालूम है कि यह मुश्किल है, लेकिन इतनी बात मैं विश्वास के साथ कह सकता हूं, एक साइंस का स्टूडेंट होने के नाते, कि यह असंभव नहीं है। मुझे इस बात की खुशी है कि रक्षा मंत्रालय और डीआरडीओ देश में इसके स्वदेशी निर्माण के डिटेल्स पर इस समय काम कर रहा है, जहां तक मुझे जानकारी है। जल्दी ही इसका परिणाम देखने को मिलेगा, ऐसा मेरा विश्वास है। मैं यहाँ उपस्थित आप सभी स्टेक होल्डर से गंभीरता से इन मुद्दों पर चर्चा करने और भारत को टेक्नोलॉजी हब में बदलने के लिए आगे का रास्ता तैयार करने का भी मैं विनम्र अनुरोध करता हूँ। और जिन लोगों को टेक्नोलॉजी ट्रांसफ़र हुई है, मुझे पूरा विश्वास है कि उस टेक्नोलॉजी का पूरा लाभ उठाएंगे और उसका लाभ हमारे देशवासियों को मिलेगा। जिन्होंने टेक्नोलॉजी ईजाद की है, मैं उनको तो बधाई देता ही हूँ, लेकिन जिन लोगों ने टेक्नोलॉजी जिनको ट्रांसफ़र हुई है, उनको मैं सफलता के लिए हार्दिक शुभकामनाएं भी देता हूँ। और इस अवसर पर इससे अधिक कुछ न कहते हुए इस महत्वपूर्ण आयोजन के लिए आप सभी लोगों को मैं अपनी ओर से बधाई देता हूँ और इस सेमिनार की सफलता के लिए भी हार्दिक शुभकामनाएं देते हुए अपना निवेदन समाप्त करता हूँ।
आदरणीय मंत्री जी का हार्दिक धन्यवाद इतने ज्ञानवर्धक शब्दों के लिए। डीजीटीएम श्री हरिबाबू श्रीवास्तव से रिक्वेस्ट है कि वोट ऑफ थैंक्स प्रपोज करें।
परम आदरणीय रक्षा मंत्री जी एवं मंच पर उपस्थित सभी विशेष महानुभाव, ऑर्गेनाइजिंग कमेटी एवं DRDO की ओर से मैं माननीय रक्षा मंत्री जी का आभार प्रकट करता हूं कि उन्होंने TDF का प्रोडक्ट लॉन्च कर डिफेंस प्रोडक्ट्स की गुणवत्ता सुनिश्चित करने के लिए वेबसाइट लॉन्च कर CBRD के प्रोडक्ट की सर्टिफिकेशन एवं बियरिंग्स का पुस्तकों का विमोचन कर हम सबका मान बढ़ाया और हमारे उद्यमियों का, रक्षा वैज्ञानिकों का प्रेरणा दी। महोदय, आपका आज का उद्बोधन पूरे भारत में डिफेंस R&D इकोसिस्टम बढ़ाने में कारगर साबित होगा, ऐसा मेरा विश्वास है। सर, असली में स्वावलंबन तभी है जब हमारे देश में डिजाइन किया हुआ सिस्टम, वेपन सिस्टम हमारे अपने उद्यम में मैन्युफैक्चर हो और वो हमारी सशस्त्र सेनाओं के मानकों पर खरा उतरे और जिससे दुश्मनों के न सिर्फ दांत खट्टे हों बल्कि छक्के भी छुड़ाएं। माननीय रक्षा मंत्री जी, भविष्य में भी आपके मार्गदर्शन की कामना के साथ एक बार पुनः धन्यवाद एवं आभार। CDS महोदय, SA2RM महोदय, सेक्रेटरी R&D एवं अन्य महानुभावों का भी मैं शुक्रगुजार हूँ कि उन्होंने हमारी हौसला अफजाई करी, और बहुत बहुत धन्यवाद।
हम सभी की ओर से आदरणीय मंत्री जी का बहुत बहुत धन्यवाद। साथियों, ये हमारा सौभाग्य है कि हमारे बीच चीफ ऑफ डिफेंस स्टाफ जनरल अनिल चौहान मौजूद हैं। इस अवसर का लाभ उठाने के लिए मेरी उनसे प्रार्थना है कि हमको कुछ दिशा निर्देश दें जिससे कि हम इस सेमिनार के विषय पर गहनता से विचार कर सकें और आगे बढ़ सकें। जनरल अनिल चौहान, चीफ ऑफ डिफेंस स्टाफ, प्लीज।
Dr. Samir Kamath, Dr. Reddy, friends, dignitaries on the dais, ladies and gentlemen, friends. If you look at your program today, there is no scheduled talk of mine actually. So while sitting on the dais, it is Dr. Reddy's brainchild that I speak to you, and he's almost forced it onto me. So here I am speaking to you. Since I don't have a prepared script for this particular talk, whatever I speak will come straight from my heart, and as I think, I'll continue speaking. You know, let me start by saying that if you look at the global security environment, it's all in a state of a big flux actually. Whether you look at what's happening in Eastern Europe, what's happening in Indo-Pacific, or even on our northern borders. So these are times, even after COVID, things haven't really settled down, and this causes both challenges and opportunities for a country like us. We've learned our lessons because of the Ukraine war and system of supplies of spares and MRO facilities, but there also lies an opportunity. And this particular event which is being organized actually showcases India's opportunities which are available to us. Well, one may turn around and say, what's the big thing actually? If things are changing, things are in flux, change is the normal constant in life actually. That's the only thing which is there. But then the type of changes which are being attempted actually to cope up with this huge change, I think that's phenomenal. Let me give you some examples. So the Indian Army, we are attempting some changes, or rather transformation, under two heads. When we're looking at transformation and we're looking at modernization. When we look at transformation, we're basically looking at integration and jointness. This will ultimately lead to operational structures which join the three services together, something which you have heard about called as theaterizations. So joint operation headquarters, we can control the operations of three services. The second thing which we are attempting is modernization, which would again, in my opinion, fall under two heads. One is Indianization, and second is innovation. Well, so this is an initiative which actually the Prime Minister started right after 2014. It is Make in India initiative, and then we took it a step further, called it Atmanirbharta. So when we look at Atmanirbharta or self-reliance, if you look at the two words inside it, when you look at self-reliance, it talks about self actually. There's the first word. And when you talk about Atmanirbharta, over there also it is talk about Atman. That's your own self. So unless we self-realize this, unless there is self-realization, self-actualization of ourselves, our capabilities actually, if we don't do that, then any kind of capability which we want to acquire, whether it is the armed forces or whether it's the DRDO, it would be rather difficult. So first is your own understanding, your soul actualization, which is important. As far as the armed forces are concerned, when we talk about self-actualization or self-realization of our capabilities, it's not only restricted to the manufacturing sector or acquisition of capability in terms of hardware. It's also conceptual in your mind, actually. Okay, what kind of strategy you will have, what kind of tactics, etc. you will have. So what kind of doctrines will you have? So there should be Indigenization content in that, because that it will lead to an element of surprise in battle. So these are the kind of initiatives we are attempting. You may again say that if you look at, let me talk about Indigenization, which is the theme actually of Atmanirbharta everywhere, wherever you go. Besides, if you are in DRDO, it's also innovation. Otherwise, it's Indigenization and innovation together. So when we look at both those things, someone may turn around and say, what's so new? We've heard about those positive Indigenization lists, we've heard about defense corridors, we have heard about ease of doing business, etc. So let me try and say that it is slightly different this time, because it's the services which are going to take a lead, and if they derive this thing, innovation and Indigenization, then I think the whole process will be given the due momentum, and it's likely to succeed in a faster kind of a manner. Let me talk about the subject which is important, about which there will be deliberations after I leave. It's about the aerospace industry. Honorable Raksha Mantri has spoken at length about what needs to be done and what are the expectations of the country. It's been a long time actually, and since our aviation sector has not been able to kind of indigenize things, in spite of the huge requirement, the market, if you look at our civil aviation industry, is expanding many folds, and similarly, it's also the military aircrafts and military engines. The market is huge, the volumes are huge, and yet we don't have this indigenous capability 100% in avionics, where it's aero engines, landing gears, and connected technologies. I think, if we have to achieve this, we got to follow multiple paths for achieving this. There could be a strategy behind it. There could be a strategy when we develop things right from the beginning. So design along with some foreign OEM, which we are attempting. That would be one strategy in which your design technology is completely available to us. There could be already developed engines in which we get manufacturing technology. So we kind of build to print, that is one. And then we start the learning curve. Third strategy could be, which we started earlier in case of Kaveri engine, that we try and do things independently. So that could be another process, because we need to develop. And in my view, if all this is to be developed, actually we have to have an intellectual base, to people who are studying MTech, who are doing degrees in aeronautical engineering, etc. Then another strategy could be, we already have, in case of some aircrafts and some engines, which are already manufacturing over here, like Sukhoi's engine. Now, in those kind of engines also, a large number of spare parts, etc., we are still dependent on outside. So there should be a strategy not only to develop engine right from the beginning, but also its spare parts, also the technologies required for its manufacturing, etc. So a comprehensive strategy needs to be developed, not just developing an aero engine right from the start. So the whole ecosystem which is connected with this, if we look at that, probably that will pay us far more and better dividends than looking at singly at an aero engine. That was all, gentlemen, from my side. I wish the seminar all success. I am sure, I just bit impromptu kind of a thought process in giving you some kind of a strategy, but people who are prepared for this particular talk, they would have thought about it more, and I'm sure their pulse of wisdom will do good to the seminar than what I have spoken. Thank you very much.
With deep sense of gratitude, I sincerely thank Chief of the Defense Staff, General Anil Chauhan, PVSM, UISM, AVSM, SM, VSM, for giving such a knowledge-increasing talk. Sir, we will keep looking for guidance from you as we move ahead in the direction of this seminar. Now, I also do not want to miss this opportunity of taking guidance from Vice Chief of Naval Staff, Vice Admiral S.N. Gormade, PVSM, AVSM, NM, ADC. Sir, please guide us by your talk. It is also not a scheduled talk, but leaders like you can definitely guide us and increase our knowledge and take this seminar in the right direction. Vice Chief of Naval Staff, sir, please.
Dr. Sameer Kamath, Secretary DRDO, Dr. Satish Reddy, Scientific Advisor, dignitaries, head and dignitaries on the dais. Firstly, as was brought out by Chief of Defence Staff, of course, he gave a very, very comprehensive impromptu speech. But what I would like to say that this process of indigenization and Atmanirbharta has really taken momentum, and DRDO has been taking this forward for many years, but it has gained the great momentum now, which must be sustained. And really, for our nation, because Atmanirbharta cannot happen in pockets. It's a whole of nation effort. It has to be the R&D agencies, DRDO, it's the academia, it is the industry, and the entire system, defense services, have to work together to achieve the same. And this can be achieved because it is the grand moment of our nation at present. We have the complete government machinery backing it. We have the complete ecosystem. We have the young generation with us. We have the private industry coming up. So all this together put in, I think we have the great moment to take each and every step forward. And we must not lose any opportunity for every situation. So we can develop a defense ecosystem which will take us through from womb to tomb for every system, and that will have positively a dual purpose use, because a great amount of defense systems are dual purpose and they are in the civilian industry of use. And with that part, the economy will be driven, there will be more demands and there will be more requirements. So I think this is something which I would I'd like to, and I will wish the seminar a success, because if the defense ecosystem, aerospace is part of that defense ecosystem. If you work at the defense ecosystem as total, aerospace is one important part of it, which will there. I wish the seminar a great success and wish each and everyone great success, because all of you are a great amount of contributing towards creating this ecosystem. Thank you very much.
Thank you, sir. We are indebted to you for accepting our request at such a short notice, and the guidance given by you will definitely be very useful for taking the seminar forward and meeting the objectives. Friends, ladies and gentlemen, today among us we have Scientific Advisor to Raksha Mantri, Dr. G. Satish Reddy, a world-renowned defense scientist. Dr. Reddy has led the development of critical defense technologies and systems. So I'm just cutting short, as sir is saying. We all know him. So his biodata is flashed. And sir, please guide us.
Very good afternoon. Dr. Sameer Kamath, Secretary DRDO and Chairman DRDO, Vice Chief of Naval Staff, Admiral Gormade, Dr. Tessie Thomas, Director General Aero, Dr. Haribabu Srivastav, Director General Technology Management, the Director Generals of DRDO, the Deputy Chief of Air Staff, all other officers, both from DRDO, Armed Forces, and friends from industry who are present here. Very good afternoon to you, all of you once again. Looking at the theme of the seminar and also hearing Honorable Raksha Mantri, the second part of the theme, way forward for the development of aero engines, is the theme. The way Honorable Raksha Mantri has stressed upon that particular point, I think he's the development of aero engines. He is the focus of the aerospace community in this country today. That's the very clear message coming from the leadership of the country and the entire techno, managerial, scientific community in this country. Whether it is, we are talking about the engines for the 5th generation fighter aircrafts, or we are talking the engines for the UGAV programs, or we are talking about the engines which are required for various other aero vehicles. Like today when we talk about aero vehicles, the scramjet engine is one of the important things which is required for the hypersonic cruise missiles, is one important thing. Second, also we haven't developed an engine which is required for a supersonic cruise missile, is another important thing. If we have to take up a program in a different form what is than the present existing BrahMos, a cruise missile, supersonic cruise missile, we need to have a supersonic engine, ramjet engine, liquid or solid or whichever it is one more important thing. And third, and then in the same sector, the subsonic cruise missile engines, whether we talk about our STFE engine, or we talk about other cruise missile program which is equivalent to TR-40 engine or whatever it is, or various other configurations, whatever we think, we need to have these engines developed. This is the family of aero engines. I am not talking about other solid fuel, ducted ramjet engine or other engines and all that. Primarily talking about this type of a cruise vehicles and aircrafts. These are the engines which are essential, which calls for many technologies which are need to be developed in the country, right from materials technologies, various materials which are required part and parcel of this engines development is one of the very important programs what we need to take up. And similarly, the processes what are required to develop these various parts which are required in this engine, mechanisms, technologies, engineering, this another important one, along with the necessary infrastructure what is required in the country. Talk about whether it's the hot end parts, we are talking about compressors or pumps which are required, high pressure ones or whatever it is, or talking about single crystal blades and various other things which are required is one thing. Infrastructure and technology development and production capability of these parts is one of the very important things what has been discussed. In this particular aspect, let me mention the ISET which has come up between the two countries, between USA and India, initiative on critical and emerging technologies what has been there. There have been a very strong communication and there has been a strong positive response from the government of USA that there will be a cooperation on various technologies including the engines. Is one of the things which has happened recently, that world is also coming forward to collaborate, cooperate in this direction. Wherever we have the gaps, we can have collaborations, technological collaborations, whether it is in the basic research and applied research is one of the aspects in this aero engine sector what we need to look at and develop these various engines which are required quickly and try to make all our programs which are there are successful is one aspect. Second, when you look at it as vehicles development, even that the roadmap is very clear in the aerospace sector, whether in the aircrafts, we have the LCA Mark II, we have the TED-BF, we have the 5th generation aircraft, probably upgrading to the 6th generation, or the TED-BF which is required for the twin engine tech-based fighter aircraft for the naval applications is one side. Second, the world is clearly moving towards unmanned combat aerial aircrafts, not aerial vehicles. Let me first talk about aircrafts. Is one important program where many nations are working, where we also need to look at it, and working on that is one of the important things. These are not very far off. A lot of people are working and a lot of things have been working out, and today it's a unmanned self-driving autonomous cars is a reality. Today in the world, wherever you go, you can be seeing, and then people are using that and trying to see that an autonomous car which is able to drive you, taking from point to point, and that too actually learning the structure of the roads and traffic nature and things like that in the first 10-15 minutes, understanding to AI is a reality. So the reality is going to be very fast, very quick, even in the aviation sector, and so we need to move to that as another aspect of it. And thirdly, when we talk about UAVs, one thing very clear is, I am not talking about today the mail or other systems which are being developed or trying to improve those systems, all those things. One thing, very clear message is, we need to have a stealth hail. It is not just a hail what we need is, it is a stealth hail is one thing, which again multiple nations are working in the world, and we are able to see which are coming out with this. There is no point in having a simple hail being developed also today is not the requirement, is the clear-cut requirement, the message from the world is that we need to develop a stealth hail. And then looking at the recent developments, what are happening worldwide, and then there are lots of conflicts between the couple of nations, what are happening. So the surveillance, aero surveillance or air-based surveillance is an important aspect. In this, I think one activity what we have to take up very seriously is the stratosphere vehicle. Having a very long endurance and then having necessary capability to carry out the surveillance payloads is one important program. Actually, as a futuristic and advanced programs, what we need to look at it is the stratosphere program is one of the important things what we need to look at it. And even in when you look at when we are talking about 5th generation fighter aircrafts and things like that, how well we can improve the system to improve the RCS of that particular system, coming to as minimal as possible. As you know that today, as you are going more and more towards the stealth technologies, similarly the systems which are under surveillance are also improving and trying to detect the systems which are stealthy in nature. So we need to further and further improve these systems to see that the long range detection capability of these 5th generation systems, aircrafts or whatever it is coming up, you are actually able to see that is minimal at long distance, you are able to detect them. So the technologies which are required for that, the materials or the engineering or the design of the airframes or whatever it is required on that is one of the important things what we need to continuously concentrate on that and try to see that these systems are improved upon. Then over and above that, when you look at it, today, the way the technologies and the materials and the composites is improving today, trying to have lighter and lighter systems which gives you a better performances in terms of the capabilities or in terms of the endurance and all that is one more important thing. With a completely health monitoring system which is able to provide all the data is one of the important things. In fact, when we were talking with some of those giants in USA the other day, one of the topics proposed is that a continuous health monitoring system with integrated sensors along the complete structures of the aircraft onwards to the various subsystems is one of the important aspects what has been projected by one of the very important company which is working in this sector. So this is one of the important aspects what we need to incorporate and see that we are able to predict the failures and predict the health of the system, and the fatigue of the system is also one of the important things which we need to incorporate and see that becomes part and parcel of the system. Then coming to the various systems or avionics and other parts which are there in that is again is an important aspect what we are today talking about it. We are now today, let's say just we talk about navigation today. Navigation for an accuracy today, the aircrafts are heavily dependent on global navigation system today. And there is a sea change in the thought process globally. In fact, I think about 1 week back there was a small seminar on working with non-GPS based high accuracy navigation systems is one of the important aspects. Worldwide many people are working. In fact, there is a startups in California which has worked, which are Indians who are there in the startups of the California who are working on these technologies, using multiple methods, whether it is passive system or active system, using it and trying to see that in a jam environment, and GPS signals availability is an issue which we are seeing in the worldwide, where particularly in the conflict what is there between Ukraine and Russia, the way the GPS is getting jammed all through the entire area of warfare, need to have the systems which are not dependent on this global navigation system. Continuously is an important requirement where we need to look at it, whether it is sensor based or multiple aiding systems which are based on various new techniques which are coming, is one of the important aspects again in the avionics what we need to look at it. And then of course various payloads what we need to look at in the avionics, and trying to see that they are all state of the art with each and every system incorporating AI into it. And one thing is very clear, down the line, maybe 1, 2, 3 years, there will not be a system without AI into it. This is a fact. So we need to see that the artificial intelligence to be built into the system very, very, very clearly, and try to see that in each and every system we are able to build in, and try to see that this area we are not lagging behind and we are in the front end area, and try to incorporate the artificial intelligence features into it. Along with that, today as the communication with the aircraft is also improving, and there is a lot of communication needs and a lot of data being is also used into these aircrafts and aviation systems, building into it cybersecurity into this aviation sector is a must. And we need to see that in each and every system, the cybersecurity aspects are created, incorporated right at the design stage, is another important aspect what we need to look at a top level, not getting into the details of each and every subsystem, their technologies and all that. At a top level, when we look at it, these are some of the technologies what we need to incorporate. Leaving aside, I'm not talking about various equipments or various missiles and payloads what need to get into it. Look at today, I think entire world is looking at compact high energy systems which can go into airborne platforms. Is one of the important things, how to minimize the size and weight of the high energy systems, how we can incorporate in the airborne platform and see that it is effective is one important. There are people who have worked, maybe people are going to 100 kilowatts or maybe 150 kilowatts is a reality today, but ground-based systems. But can we see that we are able to provide a system which is compact and providing this type of a ranges for a system which can give you say 100, 150 kilowatts, but still it can go into airborne platform, is one thing what we need to look at it and see, as the world is very, very fast moving into today. Today, if you look at couple of companies have already come out with this, probably around 120, 130 kilowatts is what public domain information available is, that people are able to do it in a ground-based system. And they're also talking about 30 to 50 kilowatt systems on board various aircrafts. This is one thing. Similarly, radars, whatever the systems what we are trying to have, radars on these systems, whether AESA radar, what we have developed, trying to have ranges which are much beyond 120, 130 kilometers, and trying to have these systems on that. Yeah, some of the couple of avionics and also the EW systems or the surveillance systems having a much higher sensitivity, are some sensors and payloads what we need to incorporate on the airborne platforms, which we need to look at it and work on those things. So this is a top level scenario where we need to head in the aerospace sector. I'm not talking about the space in detail. As you know, the way the space sector is emerging today, right from the launch vehicles, whether it is small satellite launch vehicles capable of launching 150 to 350 kgs payload, simple vehicles. From there onwards, the satellites, the capability of the satellites, the payloads in these, the space, the bus, satellite buses, what they are trying to do, and the propulsion technologies varieties of propulsion technologies, green propulsion, or electric propulsion, or plasma-based propulsions, and all those things. And now people are trying to go from low Earth orbit to medium Earth orbit, and slightly above that a higher orbit are the technologies which are people looking at in the space, leaving aside the specific payloads and specific other capabilities what are being built into the space. So these are some of the areas, again, space-borne sector, which are required, which need to be seen, and the space situational awareness. Space situational awareness and space weather. These are, again, two important aspects what we need to look at in the space domain. So this, I thought, these are some of the areas what came to my mind, projected to you, which I'm sure that you will be able to deliberate in the various sessions in this seminar. We'll be able to come out with a clear roadmap for the aero engines and also for the advanced and futuristic technologies in aerospace sector. My best wishes to the seminar. All the best to you. Thank you. Jai Hind. Namaskar.
Thank you, sir, for the thought-provoking keynote address, which has set the tone for the seminar for going forward. Friends, our research team at NIAS, along with DSTA of DRDO headquarters, has carried out extensive studies on critical weapon systems, technologies, sensors, and platforms for national security. Detailed reports covering important technical parameters, current state of technology, and future direction of development on battle tanks, unmanned combat air vehicles, tech-based combat aircraft, electronic warfare and hypersonic weapon systems, conventional submarines and radars have been prepared by NIAS along with DSTA. May I request Dr. Shailesh Nayak, Director NIAS, and Dr. Ranjana, Director DSTA, along with their teams to come on the stage, please. I request Secretary DDR&D and Chairman DRDO to release the reports in the august presence of our scientific advisor to Raksha Mantri and Vice Chief of Naval Staff, DG Aero and DG TM, please. Friends, these reports will go a long way in setting the policies and further planning for DRDO and various other organizations who are working in this direction. So these are 6 reports, friends, being released together. Friends, DRDO in association with Messrs. Verdant Telemetry and Antenna Private Limited, Cochin, under the TDF scheme has indigenously developed a very ultra-high frequency blade antenna JD202 for Tejas aircraft with technical hand-holding by ADA DRDO. This antenna will provide navigation and communication support to Tejas and its variants while meeting all the customized environmental specifications and achieving omnidirectional reception. I would like to request Honorable SA to RM to launch the system in august presence of Secretary DDR&D and Chairman DRDO, Vice Chief of Naval Staff, DG Aero and DGTM, please. DG ADA, DGTM, Shri Sankariya Maida, Director TDF with team, Shri Louis George and Shri Ravi Naidu from Verdant Telemetry and Antenna Private Limited with the team to join on the dais, please. Honorable SA to RM, please launch. Friends, as we are coming to the end of plenary session, I sincerely thank SA to RM Dr. G. Satish Reddy for giving his guiding talk. I also thank Vice Chief of Naval Staff for this session for giving his valuable talk. I thank DG Aero and DGTM to be present during this ceremony. And now we come to the technical session. And I would like to submit my apologies for leaving out certain formalities, that is handing over the token of appreciation, and I will be sending them to the speakers as we are slightly late for this session and our next speakers are waiting. So in this session, as we come to technical session, eminent speakers will share their perspective. First, we will have perspective on the subject from Deputy Chief of the Air Staff, Air Marshal Narmadeshwar Tiwari, Ati Vishist Seva Medal, Vayu Sena Medal. I will briefly touch upon his biodata and detail will be flashed on the screen. Air Marshal Narmadeshwar Tiwari, AVSM VM, took charge as the Deputy Chief of the Air Staff in Air Headquarters on 1st October 21. He was commissioned in the Indian Air Force as a fighter pilot on 7 June 1986. He has flown over 3,600 hours on various types of aircraft. During his career, he has held various staff and command appointments. He has been a qualified flying instructor as well as an experimental test pilot. He was involved in the flight testing of the LCA from 2006 to 2009 and has many firsts to his credit, including the first night flight of the LCA and the first landing at Leh. Prior to assuming charge of the DCS, the Air Marshal has also tenanted the appointment of Assistant Chief of the Air Staff Projects and Assistant Chief of the Air Staff Plans at Air Headquarters Vayu Bhavan. For his distinguished service, he was awarded the Presidential Award of Vayu Sena Medal in 2008 and Ati Vishist Seva Medal in 2022. DCS, sir. Yeah.
Good evening, ladies and gentlemen, distinguished guests. First of all, it gives me great pleasure to be here today and speak on this important topic from a user's perspective. And I think if you go through my biodata, I'm eminently qualified to speak on the user perspective because I have worked a lot on the DRDO side with the LCA right from 2006, and before that on many other projects where I was part of the AST and a lot of weapons and systems that we developed together. And also from the other side, when today I sit in Air Headquarters as the Deputy Chief, and before that in my previous positions, when I look at systems being inducted and with this focus on indigenization and Atmanirbharta, I think what I will talk today is not so much about the technical aspects, but as a user, what we expect from DRDO and the industry, because finally we have to work together as a partner so that as a customer we are satisfied and we can look at a product with a gainful utilization for many, many years to come. And that is something that we should look at, because as a user, two things are very important for me. One is the timeliness of the product, and second is the follow-on support. And these are two things that, from a technology perspective, you should not lose sight of, because each technology has a certain time period. And if you find that technology, if design and development gets delayed, you're always behind the technological cycle. So having the right product at the right time is very, very important, because warfare, as you know, has a changing dynamic. What was top of the line or state of the art today will be obsolete tomorrow, and it carries on like this, and change is the nature of the business. Therefore, we expect that a product is developed in time, and it is developed as a full system. Sometimes we lose sight of this aspect because we are so involved in developing a product that we don't know, or we don't focus on how it will be utilized in the field, where you have to deal with people of average intelligence. They are not scientists who work on the tarmac, but yet they are the most important aspect because they are ensuring that that capability is available on the platform. So you must design from that point of view that it can be utilizable by an average intelligent person who is working day and night to ensure that this capability is available to us. So when you develop a system, don't look at it from a point of view that you're going to sit in a lab, do the testing, the product goes out, flies once in maybe 2 or 3 days, and that's it. Because when you are in the field, you don't have the best of facilities available. You fly many missions a day, and in all those missions, that system or that equipment needs to work. Therefore, it is put through a much more tougher paces, and that is something that we need to work right from the beginning, that when you take an item on the field, you not only have the equipment, you have to look from the point of view of support, which is the ground support equipment, the ground handling equipment, the tools, the testers. So someone has to look at this complete package, because without this complete package, the system is actually incomplete. And this is sometimes we forget, because we focus on the main things, and the smaller items, we forget about it. We have learned it over the years, but I'm sure with all the experience now, we will get better to it, but it's a very, very important aspect. Similarly, the design driver for any system has to have operational input. 2 or 3 things are very, very important. One is to have a fairly simple interface, which I said a person of average intelligence that can deal with on the tarmac or on the field. The second aspect is that it has to have a small logistical footprint. If you see outside in Aero India today, you will have aircrafts which come with many support systems. You have aircraft which come with a very small trolley, which is enough, and you can deploy, at a very quick notice to forward airfields with, very limited facilities. If you please remember that if you have a bigger logistic footprint, it not only involves taking the aircraft, but you have to take the entire logistical footprint along with you, which involves transport support, the various power systems, various air conditioning systems, and sometimes even, laboratories or, big testers. So when we design systems for use at the field level, I think this has to be one of the key design drivers. And here, I must tell you that no one can better explain to you than the operator. So having the operator input at the right time in the design is very, very essential, because once the design is frozen, we all know it's so difficult to change things. Also, another aspect which I must ask you to think about is that we talk of spiral development. So that is a very, very important aspect, because you take, for example, a radio or a weapon system. Now, when you develop a weapon system, invariably you find it comes either with a seeker, with electronics, with a, the rocket pack, or a launch mechanism. Now, over a period of time, as you evolve, you don't change everything completely. You start with incremental changes, and over a period of time, that incremental changes actually leads to a new weapon. So you develop a family of weapons based on one fundamental, foundation, because that keeps your ground support equipment, your loading trolleys, your testers, there is a lot of commonality, which is very, very important when you come to, utilizing in the field because of inventory management. So if you see any weapons, you take the AIM-9 class of missiles, it started, way back, 30 to 40 years back, and yet today you still have the same missiles, but a much better and a much newer generations. But the basic form factor, the basic, the equipment that goes around it, the commonality of equipment has remained largely the same. And that is something you need to work on, because if you start with a certain class of weapon, please ensure that the changes are incremental. A new weapon which mates doesn't require a new tester, a new loading trolley, a new ground support equipment. These are the things that will ensure that when it gets inducted into the field, it is much, much easier to happen. And lastly, I will just take one small point. As a feedback from the user, it is very, very important for you to listen to the feedback, because sometimes what you see in the lab or in a controlled environment is very different from what you see in the field. And the paces that you put through in the actual field is much, much more rigorous than what you can do it in any testing. We have all been involved in testing, whether it is, in the labs or actually in the field, but when it is put through its paces in actual operations, sometimes shortfalls do come out in design, or sometimes some iterations are required in software. So it is very important to get a feedback mechanism set in place, so that when weapon systems or various electronic items, or even complex system like aircraft are inducted, you have a feedback mechanism and a team working to improve this aspect, because this is what is going to improve the user experience, and it will also ensure that the feedback comes quickly back into design and you're able to move forward to the next stage. So I think with these thoughts, I will leave you to think about it, and I'm sure that as we progress, there are many good things in store for us, and as a service, as well as with DRDO and the industry, I'm sure we can work together to make it happen. Thank you very much.
User perspective leads the technology and product development cycles, and I sincerely thank DCS sir for guiding us and putting us on the right track. Thank you, sir. Now I request Dr. Girish S. Devdhar, Distinguished Scientist and DG ADA, to provide technology perspective. Dr. Girish S. Devdhar did his BTech in Electrical Engineering, MTech in Controls and Instrumentation, both from IIT Bombay, and PhD in Control Theory from University of Waterloo, Canada. He is a lead member of the National Control Law Team for LCA and is Project Director CLAW since 2016. In 2013, He took over as the Technology Director, Integrated Flight Control Systems, ADA, and held additional charge of Associate Program Director, New Programs and Systems. From 2005, he is involved in the design and development of flight control system for the Indian light combat aircraft using both classical and modern control synthesis techniques. On September 30, 2021, he has assumed charge as Director General ADA. Dr. Girish S. Deodhar, sir, please.
Good evening. Secretary DD R&D Dr. Samir Kamath, Deputy Chief of Air Staff Air Marshal Tiwari, fellow DGs, dignitaries. At the outset, I would like to assure Deputy Chief that for us, user is the king, and the voice of the user is the most important voice for us. So I will, in a short 10-minute talk, I will talk about some of the technology perspectives which we feel are very critical for the future. Does the presentation work?
Yes, sir, it will work.
How do you move it?
How? Because
I think.
next slide.
Acha, it's come. Okay. Today, we have developed quite a few indigenous capabilities, design capabilities, thanks to the LCA program. So, for example, all the 4th generation critical technologies are matured, whether it's aerodynamic design, fly-by-wire flight control, avionics, composite structures, even flight testing, which DCS himself has contributed in a big way. So all these things are in place today. Next. And more importantly, we have a design ecosystem in the country. So there are more than 200 work centers working all over the country who have contributed to the design, MSMEs, academic institutions, PSUs, CSIR, and so on, DRDO labs, so on. So all this is now available for us to take us ahead in, for the future aircraft programs. Next. For the future programs, the conventional technologies like structures, control, sensors, avionics, even stealth to some extent are mastered, or if not, there is a work to be done, but there is a clearly well-defined roadmap for these technologies. So I will not be talking about this at all in this talk because it's just 10 minutes. Next. I can use this? Okay. So these are some of the critical emergent technologies which have to be tackled, and this is what will distinguish the aircraft or make it stand out from the others. And these are some of the ones which we have already started working on. In fact, we feel it's so important, we have made a separate directorate for it, for all these technologies, to focus on that. First is the optionally manned cockpit, the electronic pilot. I'll be covering a little bit about this, manned unmanned teaming, and as SA2RM mentioned, AHM, IVHM, or aircraft health monitoring. Next. Oh, okay, I can do it. So about, first of all, autonomy. Today, autonomy in combat aircraft can give us a tremendous edge for efficient operation, reducing the pilot workload, enhancing safety. And today in Tejas, we have many autonomous features already in place, advanced recovery modes, carefree maneuvering, and so on, and the naval aircraft doing automatic ski jump takeoff. But there is a lot to be done. In fact, if you look at the pyramid for autonomy, we are probably in the middle of it. The yellow portion is where we are with auto recovery modes and so on. So we have to progress to the next level, and that final one will be the decision-making capability of the computer in the aircraft. And this we call as the electronic pilot, which we are initiated. So today, with all the advancement in all the sensor technologies, and also with SDR coming in with data-centric operations, the amount of information in the cockpit is enough to saturate the human intellect and motor skills, and it will affect his operation itself. So the very systems that are helping the pilot are threatening to limit his capabilities, limit his effectiveness. So we are looking at a completely new role for the pilot in the cockpit, and this, as DCS mentioned, we sat with the pilots and defined what needs to be built into the system to improve their effectiveness. So the electronic pilot is essentially an aid to the pilot in the whole mission to increase his situational awareness, reduce the workload, amplify the human decision process. Today we are planning it as an advisory role. to the pilot. But tomorrow when we go for optionally manned cockpits, this can become fully autonomous operating the aircraft. That is the target. So electronic pilot was just a word. How do we put it in? How do we put it in place? So we went into the pilots' minds and took out what are the things which will help them throughout the mission and broke it into functional components which can now be specified to say academic institutions, startups and so on to develop using AI/ML these modules. So the modules are basically information fusion, situation assessment, combat identification, automatic target recognition, electronic warfare decision support, dynamic route planning, combined vision system, and automatic collision avoidance. So these are the key technologies that we have now started working with academic institutions, MSMEs, startups, and all various organizations in the country, and of course the traditional CSR labs and the DRDO labs. The next technology we are focusing on is manned-unmanned teaming, and this is because it is not too far away when manned and unmanned vehicles are going to work together coordinatingly in an environment. And of course, unmanned vehicles give a great advantage because they can be used in dangerous missions, difficult missions, dull missions, and so on. They can cover additional grounds, complete additional actions, communicate with more information, and they can help to improve the situational awareness for the whole fleet. So for manned-unmanned teaming, we have the technology aspects are having secure data links, high bandwidth secure data links, information fusion, parsing of information so that you don't get a huge mass of information from the unmanned assets, and enhancing the level of autonomy for unmanned assets. There's no point the pilot in the manned aircraft controlling all the unmanned assets, so that part has to be built in, and the human-machine interface for command and control of unmanned assets. So this we are planning on the LCA Navy platform and working with unmanned vehicles as a target concept. So we have already initiated this activity of doing a manned-unmanned teaming with a few unmanned assets and proving this technology and evolving the human-machine interface for the manned aircraft to work in this environment. Last but not least, and this was mentioned by SA2RM, is aircraft health monitoring. This goes well beyond humps. As he also mentioned, it is comprehensive throughout the whole aircraft, and it has to be done from the design stage. We have to build in the sensors and all the required facilities right at the design stage. It can't come as an add-on. Of course, health monitoring would help to reduce maintenance, downtime, operating costs, and to maximize the utilization and also availability of the aircraft, which is critical to the user. And doing all this without compromising the current safety standards that we have achieved today. So AHM, of course, the diagnostics part today we have a good handle, but prognostics is what is the key area of research. Prognostics for all the LRU systems, and on top using, say, deep learning techniques and also physics-based modeling. So this is the activity we are concentrating on, and this would help to have condition-based maintenance rather than scheduled maintenance and reduce the maintenance activities of the user considerably. So I think in 10 minutes, I just wanted to highlight some of the key aspects that we are looking for the emerging technologies. Thank you.
Thank you, sir, for providing the technology perspective. Who better than you for this thing as you are heading the ADA, Aeronautical Development Agency. Now I request Professor Sudarshan Kumar, Head of the Department Aerospace Engineering, IIT Bombay, to present the academia perspective. Professor Sudarshan Kumar is Institute Chair Professor and Head of the Department in Aerospace Engineering, IIT Bombay. He completed his Master's and PhD from Aerospace Engineering, IIC Bangalore in 2004 and worked as a postdoc researcher in Tokyo University, Japan. He joined Aerospace Engineering, IIT Bombay in 2006 as Assistant Professor and made significant contributions to the field of combustion and propulsion. For his outstanding contributions to the field of combustion and propulsion, he has been awarded several awards, including IIT Bombay Research Publication Award 2022, IIT Bombay Young Investigator Award 2012. He has indigenously developed an anti-hail gun system for saving the apple crop of farmers and horticulturalists in Himachal Pradesh. He has also developed an indigenous technique for accurate laminar burning velocity measurement of pre-mixed fuel-air mixtures at high pressure and high temperature conditions simultaneously. His detailed biodata is flashed. Professor Sudarshan Kumar, please, sir.
Yeah, thank you for a nice introduction. So, today I'm going to talk about some of the ideas which were recently discussed in the recent conference ISEBE 2022, which talks about what's going to be in the future for next, say, 10 years, 20 years, or 30 years in the field of the propulsion. Plus, I will also talk about some of the ideas which have been being discussed during last couple of years in the field of the propulsion. So, yeah, so going into the areas, we have various systems into air-breathing systems and non-air-breathing systems, where we have civilian applications, military applications, ramjets, scramjets, pulse detonation engines, piston engines. Then we have, in non-air breathing, we have missile systems, launch vehicle, and satellite propulsion. Now, in gas turbines, to talk some of the concepts which are being discussed recently, what we have is, like instead of having the conventional systems, the ideas are being discussed. Like, how about installing a system in the wake which can help reduce the drag significantly over here? That's being practiced, and there are other configurations which are being also proposed and being discussed, which may see the light of the day in another 10 years or so, like aft-mounted fans or blended wing bodies or the tube and wing configurations and so on. Okay. And what we have today is something like the systems which are somewhere over here, but where do we aim to go for? So the typical aims are going to touch over here in next 10 years or 20 years. Through these aft rotors or through the application of some of these modifications in the heat addition cycles in the conventional these turbine cycles. Okay. Now in this, some of the ideas are like, one of them is flameless combustion. So here what we have is like, the challenges are having a system where the reaction rates are very slow, but the challenge comes the spray formation, the mixing, the combustion, everything happening very slow, whereas what we want is very, very fast in a gas turbine engine. Now, achieving this with low acoustic and pollutant emissions, as well as with very low the temperature fluctuations. Some of the merits, what we get is reduced IR signatures with uniform temperature field, which would help us enhance our life of the combustor components as well as other engine components. Some of the applications, but the important point is what you see is the reduction in the NOx emissions, and this is how we get to see when we compare a conventional combustion system with a flameless system. And what we see is over here a significant jump in the acoustic systems, making our systems more quieter, less noisy. Some of the developments where we see more uniform temperatures obtained in these systems. And then we come to manufacturing technologies, where what we have is like this ballistic manufacturing for reduced weight, and then again in the turbines better cooling, which would lead to enhancement in the performance of the system and better and more efficient systems. Now, we are also discussing the other options of the fuels. Like a lot of talk is going on about from the jet or SAF to hydrogen-based systems and gaseous SAF systems. Now in this, although they look very interesting, but what we have is like with this LH2, easily ignitable, low detonation limit, metal embrittlement and sealing. Like hydrogen can be liquefied only at 20 Kelvin temperature. Can we have systems? Do we have the infrastructure? Do we have the systems? No, we don't have. But we need 30 years to develop everything so that by 2050 we can target that we are going to have the systems which are going to work with hydrogen. It needs at least 30 years. So we need to invest today with open heart. It's not going to be a problem like we invest today and tomorrow we are going to get the result. For instance, there was one Professor Insuk Jung in Seoul National University. 10 years ago, he showed an experiment that if you pressurize the hydrogen gas to 350 bar and there is a micron level hole, the gas expands so fast through that hole, it will auto-ignite. The biggest safety risk with hydrogen. He did this experiment in the lab. But beyond that, nobody talks about these safety repercussions with hydrogen, which we need to address. Some of the future which is being talked about by Airbus and Boeing, like using compressed LH2 and run a flight with hydrogen. Is it going to be possible? Let us see. So the system, currently we travel in a typical Airbus A320. When modified with hydrogen fuel, it's going to look like something like this, with different challenges. Now what are those challenges going to be? Some of them, if I say, full development is needed even for the fuel metering system to measure the flow rates. Does not exist even today. Unless we invest today, we are not going to have it even in next 10 years. Many other challenges are there which I mentioned over here are going to take us to the next level. Some of these hydrogen fuel supply system, infrastructure, these are the needs of the hour which we need to start the work today so that we have these systems 20 years, 30 years down the line. When we compare for the aviation or for the both defense or civilian market, you look at LH2, we talk about new infrastructure at the airport, new propulsion systems, very low density of the fuel. All these challenges are there which need to be addressed. Can they be addressed? Yes, but we need time, we need investment. And we need to believe that we need to start the work at the basic level where the academia can pitch in and help in the development of these systems to give a good start. Some of the other systems, when we talk about propulsion, we have something like RAM-assisted shells to enhance the range of our armory significantly. Then we need internal, external ballistic prediction codes, throttle level solid rockets, then modular thrust, stop and start of a solid rocket motor, thrust as and when we want. So this will help us achieve like multiple targets, multiple trajectories. Future, we need to look for hypersonic projectiles and also electromagnetic railgun. So these are some of the future technologies like anti-drone technology, electric thrusters, green solid propellants, gel propellants, which will help us have more and more energy encompassed in this system and give us better performance in the future systems. These are some of the comparisons shown over here. With this, let me make a couple of comments that just speaking about what we need to do is not enough. We also need to focus that we should hire quality manpower to get this work done. We talk about good things, but the system needs to look after that. How can we take it to the next level? My experience is system is very tough. We need to work together to relax the system to make it more friendly for the research and innovation in the country. My experience in different countries has been very good. Like I have spent 2 years in Korea, 1 year in, 1 year in South Korea and 2 years in Japan. The system is very, very friendly. But here, the system is, I find it very difficult. For last 3 years I have been interacting. If I give you just one example, there was one conference which was started for discussing just the propulsion advances way back in 1992 by Indian Institute of Science when they celebrated 50 years. It was stopped. We again started it with efforts. Now when we hosted it in 2015, we got a grant of around roughly 10 lakh. But when we again hosted it in 2023, a grant of 2 lakh was given. Where we are moving? Do we want to move forward? Do we want to do innovation? Or what is it? I'm just expressing my thoughts that if system is going to work this way, we are heading nowhere. Let us be open. Let us say faster decisions, who is responsible, how we can take it. And if you think academia is not doing it, academia is doing it. But academia needs time. You give the problem today, answer will not come tomorrow. It will take its time. We need to do investments like, we talk about the success of ISRO, but nobody talks about that ISRO started its work in 1970. And today they are getting success. Similarly, for DRDO also, for engine also, we need to give consistent support. It will happen, but we should have faith. That's all I want to say. Thank you.
Thank you, sir, for providing the academia perspective. And as you know, now government has committed 25% R&D fund for academia and industry research, and I'm sure situation will improve. Now I request Dr. D.K. Sunil, Director Engineering R&D at Hindustan Aeronautics Limited, to provide the DPSU perspective. Dr. D.K. Sunil, Director Engineering R&D, started his career in HAL in 1987. He was Program Manager for 5th generation fighter aircraft for avionic equipment to be designed at SLRDC. Under his leadership, new technologies were developed like high power radar power supply, voice activated control system, combined interrogator transponder, which have become now growth areas for the company. He also pioneered collaboration with IIT Kanpur for data links and IIT Hyderabad for voice recognition technologies. In the last few years, he has focused on new areas such as engine control systems, design perspective plan, and improving collaboration with IITs and startups for new technologies. He has led design projects at equipment level as well as systems level for aircraft and helicopters. His experience covers the whole range of design activities pursued at Hindustan Aeronautics Limited design centers from LRU to aircraft level. He was promoted as Chief Designer SLRDC in July 2021, assumed the office of General Manager SLRDC in June 2022, and taken over as Director Engineering R&D from 29 September 2022. Dr. D.K. Sunil, sir.
Thank you. Thank you for the long introduction. Ladies and gentlemen, I think I will be presenting HAL has been a TPSU involved in aeronautics for the last 7 decades plus. And I think I'll be looking at mainly the kind of efforts that we are making. So you will be seeing a lot of individual efforts that we are highlighting, with I will highlight, which are related to what we think is the way forward. Of course, as you are aware, HAL is the premier aeronautics company in the country, and we, as you can see, we support roughly 3/4 of the fleet of the country for the airborne aircraft. We have the R&D centers across the country, each specializing in a special area: rotary wing, aero engine, aircraft systems, avionics, and so on. This is our journey in the fixed wing. As you've seen right from we have Kiran, Ajit to HTT-40 today. This is our journey in the rotary wing where we moved a different class of helicopters. We also have a very big engine portfolio, and I would like to point out specifically, today we are working on the HTFE 25 kilonewton engine, turbofan engine, and the HTSE 1200 kilowatt engine for the helicopters. We also have a small engine portfolio where we have done air producers for the Aero engine, the GT EJ60 for the AN32 engine, and the GTSU for the LCA. Of course, we have done many upgrades, the Dorniers, the Jaguars, Mirage upgrades, the Hawkeye, which we have focused, we have showcased as an improvement for the Hawk. This is HAL's thrust on R&D. We have a special R&D corpus. We have an indigenization fund. We work with startups. Today we are working with many of the innovation centers. So the future is IMRH, which has these kind of roles. It's going to be a 12 to 13 ton helicopter, and as you can see, these are the roles, communication duties for both the Navy and the Air Force. We also have the LUH civil variant. We're moving into civil, where we feel there's a big market for the LUH, which will be replacing the Cheetah class of helicopters, the 3.5 ton category. This is also the CATS, the air taming system, where we have a class of aircraft on which a couple of them we are working right now, which is the Warrior and the OMCA, that is the optionally manned vehicle. So we have taken the Kiran as the sort of technology demonstrator, where we'll build the technologies for remote piloting, where we will have the pilot in the loop initially, and later the pilot will be removed and it will become a fully autonomous vehicle. This is the way we want to go to a fully autonomous technology. The CATS Warrior, as I said, is part of the CATS portfolio of aircraft, low observability, and all the technologies will be developed in the country, either through partnering with other labs or within HAL, and the automatic flight control system will be developed on the Kiran UAV, optionally piloted UAV. Of course, we have a lot to do on the Aero engine R&D, and this is the turbofan engine which I was talking about. We have come to a very good condition where the full engine has been assembled. When you run the kilometer engine, which we have filled it on, and now we are able to run it for more than an hour. This is the full engine. We have reached idle speed, and we are able to run it for 1 hour. This is a significant stage in the development of this engine. This is the Adir class of engine. Yeah, the other major Aero engine which we are working on is the 1200 kilowatt engine for the helicopter platform. And may we have that, please? I would like to show you. This is also significant. whole engine has been As I said, this is the GTEG engine which we have developed for AN32. This has been successfully demonstrated. IDS for LCH has been integrated. This is totally developed in-house. The flight control system for the LCH has been developed in-house totally, and this will be going into the SP aircraft. Software-defined radio has undergone recently the flight trial on Dornier, Navy Dornier, and the results are very encouraging. This is equivalent to the imported system. Of course, we have a range of mission computers. And coming to the future, we have developed a health and usage monitoring system which can do prognostics based on basically the gear, wear and tear of the helicopter gears. This has been developed. We have also developed an automatic target recognition system based on AI technologies. And this is our idea is to automate the cockpit using voice. A voice-operated cockpit is what we see as the future. And this is an AI-based box which we have tested on the Hawkeye. And we have got very good word accuracy in the noisy ambient conditions of the aircraft. And this will be as a part of the software in all future audio systems in terms of having 3D capability, in terms of voice-activated capability. So this is part of our idea for the future. And as I said, this is the data links which we have for the Karen UAV we have developed specially. And a family of data links for this whole CATS scenario that we have envisioned. We have deployable flight data recorders, and of course film-based air combat simulators, which will be going into full motion simulators in the future. For the LUH, we are developing a full motion simulator, and similarly for the Dornier. Coming to this is the flight control actuators for the helicopters, the main rotor actuator and the tail rotor actuators. Both are developed and now they are undergoing certification. And this is a vapor compression machine for the AESA radar for the Su-30, which has been prototyped in this fashion, generating the heat loads of the radar. And this vapor compression machine is being developed for the LRD radar for Su-30. Of course, weapon integration, I will leave it there. So I think, in short, HAL is investing and working on a lot of technologies across platforms and across different domains which we have, right from hydraulics, avionics to the aircraft. And our vision is the future of aviation needs these small steps, and we need to work with industry to make this happen. Thank you.
Thank you, sir, for giving us the glimpse of all the technologies of HAL, our own technology giant. And I am sure similar stories are there in the other PSUs. Now, we have with us Shri Alok Nanda, CEO GE India, who will put forth industry perspective. Shri Alok Nanda has a master's degree in mechanical engineering from Indian Institute of Technology, Mumbai, and is based in Bangalore, India. He has been with GE for over 22 years and has held engineering and technical leadership positions across GE's aerospace, gas power, and global research businesses. Prior to joining GE, Mr. Alok spent 8 years at the Indian Defense Research and Development Organization, DRDO. Alok collaborates with GE's internal and external partners to maximize value for GE from India ecosystem through strategic partnerships and external funding. He stimulates a world-class inclusive work environment for the organization and propagates a culture of innovation for customer value while ensuring best-in-class talent. His high-performing team has created deep technical impact across the GE Aerospace businesses and established a successful services engineering organization in the region to support GE's key customers. Sri Alok Nanda, please.
Thank you so much. The introductions are sometimes embarrassing. And you know, for this audience, one introduction would have been enough. MEFC2, ex-DRDO, now working for GE. I think that would have been good for this audience as well. It's always a pleasure to come to a DRDO seminar when I see my senior, Mr. Siddiqui. And now I heard that the next GTRE director is Dr. Ramana Murthy. He's my batchmate from IIT Pune. So I feel really, really proud of what we have achieved and where we've come as a nation. And we've contributed a bit from GE in the growth of aviation in India. So if you are wondering where is my presentation, so it was not because I was lazy that you don't see it. Between the security systems of DRDO and GE, we could not display it today, but I'll try to do justice by speaking about it and making sure you get something out of these 10 minutes that I have speaking to this August audience. So what I wanted to do today was to give you a brief into what GE is doing in technology development for the engines of today and for the engines of tomorrow. And in keeping with the theme of today's seminar, give you a little bit of an insight of how GE develops technology and what it would take for us to do the same in India. As you know, GE is a known entity in the engines world. If you think of commercial aviation, every 2 seconds, a flight somewhere takes off with the GE or CFM technology. In next 10 years, with the number of orders we have and the backlog we have, almost 90% of the fleet in India, aviation fleet, will be flying on GE and our joint venture with Safran CFM technology. So we're very, very proud of accelerating the growth of civil aviation in India. If you think about military, I mean, you all know, we are humbled and honored to partner in the LCA program with Mark 1, Mark 2, and also the Apache aircrafts fly on GE T700 engines. We also give Navy RLM 2500 gas turbines. So it's a very proud legacy that we have of supporting aviation needs in India and creating aviation needs in India to a level where we have a satisfied customer and a progressing nation. As far as technology is concerned, I think many of you know that we were one of the first ones to start our technology center in India from an MNC perspective. This was way back in 1999. And again, we have like a team now which is developing the latest and the greatest engines of GE Aviation, the latest engine of GE Aviation, the biggest engine of GE Aviation, G9X. Almost 70–80% of that technology is being developed in India. So again, very, very proud of how we are contributing to talent development. In the morning, I was in another seminar in a panel discussion, and if I see the audience, it was all MNCs. Almost the entire leadership, majority of the leadership was either GE or ex-GE. So again, I feel very proud of getting the talent to help various industry needs from GE and our center in India. As far as technology is concerned, let me talk a little bit about civil aviation and then we'll move forward from there. if you think about the most successful engine in the narrow body era ever developed by anyone, it's CFM56 by any measure of success, and its replacement is LEAP, which is almost 15% more efficient than that. If you think about a wide body engine, G90, again, the engine which has the first engine to have composite fan blades, and in last 30, we launched that 30 years ago. Till now, other than G, nobody has composite fan blades in their civil engines, and you know, that's something we're very proud of. The successor of this very successful G90 engine is G9X, and as I said, it's again 10 to 15% more efficient than G90, and majoritarily is being developed in India. Now, if you think about the regional engines, our latest engine, Passport 20, is again 7 to 8% more efficient than its similar class of engine which was there before. So if you see, there is an industry trend that the engines that replace the previous engines are 10 to 15% more efficient. Now, what we've announced now in terms of RISE platform, and that's what I would want to spend a little bit of time today. RISE stands for Revolutionary Innovation in Sustainable Engines. You know, we are all concerned about our environment, and sustainability is a big focus. So that's the platform that GE has announced. And on top of the 15% efficiency that we got with LEAP over its predecessor, the most successful civil aviation engine, we have announced a 20% more efficiency on top of that. And you know, it's really exciting, and that's why we call it a revolutionary innovation engine. We'll have to introduce every known technology that we have ever conceived to be able to get that kind of an efficiency in a flying engine. Now, you saw one of the pictures that was presented by the IIT Bombay professor was of a conceptual model of an open fan engine. So RISE is conceived to be an open fan engine with host of other technologies which will get it to 20% more efficient. And you know, open fan engines we've been developing for last 30 years. And if you take yourself back to 30 years and think about open fan engines, the biggest problem it had was noise. But what we've demonstrated over the years with our advanced computing resources, with aerodynamics, is that now we have an open fan engine where it produces noise which is lesser than its comparative LEAP engine. It took 30 years to develop. Sometimes we get impatient with the pace of engine development in India. What I want to say is that it takes time, and there is no magic wand that anybody has to create an engine that has that kind of a technology in it. So it took us 30 years to get there, and now we are confident of announcing the fact that we are developing that engine. Now, it took us 30 years to make that announcement. It would take maybe 10, 15 years more to launch that engine. So sometimes we should be patient and embrace some of the great work that our scientists and our engineers, our colleagues are doing, and not really get too impatient, because this is a technology which takes time and it takes effort. And I really am very proud of where we've got indigenously to get the technology to where it is in India. Now, that was about RISE. Now, RISE is not only open fan, RISE has many other things. We talk about hybrid electric. RISE has a potential of hybrid electric introduction within that engine. We talked about hydrogen. We are designing RISE to be 100% hydrogen capable. And of course, all our engines, past, present, and for future, can work on SAF and blended SAF. SAF means Sustainable Aviation Fuel. Our colleague from IIT Bombay gave a little bit of an introduction to that. All our engines are SAF capable today. If we had the supply chain, we could put that in the engine and fly them. All are certified for 50% blend, and we've demonstrated over the last 2 years with several of our engines 100% plug and play capability for SAF. Nothing changes. The aircraft is the same. The engine is the same. The airport infrastructure is the same. You introduce SAF and the engine can fly. We've demonstrated that in at least 3 of our engines in the last 12 months. So if you think about the future, these are some of the exciting developments that we are introducing. On the defense side, so this was about civil aviation, and of course, the technology that you develop for civil aviation will be very useful for defense as well. But what we are doing for defense is like equally exciting, if not more exciting. Now, you know, in a mission, you need high thrust because you need to reach to the destination where the action is happening faster. But you know, now the theater of wars are expanding, and hence you need more fuel efficiency so that the aircraft can be in the air for longer and you can cover more distance. Now, in the same engine, if you have to get more thrust, when you need more thrust and more efficiency, then when you need more efficiency, that's what an adaptive cycle does. So our XA100 engine is an adaptive cycle engine. We've tested it and we've demonstrated its effectiveness. So that's something that we are like extremely proud of introducing. All that is happening today, all that is happening for future, and all that is strongly contributed by our very capable talent that we have in our center at India in Bangalore, and we're very committed to accelerate the development of aerospace in India and also invent the future of flight for the whole world. In the end, I will say just one thing. You know, we've heard various needs, various expressions of public-private partnership. I am like looking forward to a day where we can collaborate and create an engine for future for India, which we can then sell all over the world. And hopefully, in the next few years, we will start that. In the next 2-3 decades, we'll make it happen. All the best. Thanks a lot for patience listening.
Thank you, sir, for giving the perspective from GE side, that is industry perspective. And friends, the buzzword today is startup. In a lighter tone, I interpret it as the moment you start, it goes up. So the startups perspective is also very important. And as we have with us Dr. Vikram Bansal, CEO and founder, Asset Robo. Dr. Vikram Bansal has corporate work experience of about 20 years, majority of which were spent in Tata Motors Limited and Tata Aerospace and Defense. He is a mechanical engineer from Delhi College of Engineering and an avid defense enthusiast. His startup is engaged, amongst other things, in setting up India's first UAV internal combustion up to 50 HP engine, testbed and refurbishment facility. His startup also started work on the design of a new electronic fuel-injected 30 HP engine. Dr. Vikram Bansal, please.
Thank you. I would love to have a doctorate degree, but I'm yet to apply and I'm yet to get. Thank you.
I'm sure you will have it.
No, that's not. So just bringing the topic of my discussion is going to be the indigenous development of UAV engines from a startup perspective. And I hope, sir, we will not go up in the air. We'll be there for a few years to come. That's my company's name. We are incubated at IIT Kanpur. I would just like to share the Indian landscape, what I see about, I was in Tata Advanced System earlier, and I went to an Indian Air Force base about 7 or 8 years ago, and there was a searcher there. And the Air Force officer very clearly told me, Vikram, if we were to touch any system or a subsystem in this aircraft, the warranty goes. Even for a full overhaul of any of the system, it has to go back to the parent country. As an Indian, I mean, for me, that's absolutely like amazing. The second part is on the startup side. If you see, the Indian startups are now providing logistics, ISR, and loitering munitions to the Indian forces, but all of them are being powered by batteries. In fact, I have a friend here who is making a 100 kg UAV with 56 kg of lithium-ion batteries, lithium polymer batteries, which is, to me, again, to lift 10 kgs of payload. The way forward for India, of course, is definitely for the Indian startups, which are catering to the mid-level tactical UAVs, is going to be the IC engine. That's the basic premise of our whole startup. Our aim is very clear: to set up a testing, overhaul, integration, design, and manufacturing facility for internal combustion piston and rotary engines in order to enable the Indian ecosystem to offer more powerful UAVs. This is a very clear our mission statement that we have. I mean, I'm sure many of you are very intelligent about the power plant, but just for everybody, an aircraft is designed around the power plant and not the other way. So today GE is giving you a particular engine. Now a new aircraft can probably be made around that engine. That's how the aviation is. Engine propeller combination is a very critical. I mean, the difference between the last 20% of a performance of a UAV is actually about tuning the engine, propeller, and to the entire aircraft design. Almost all current UAVs in the world are using internal combustion engines. Another very interesting fact about the tactical, I'm talking about the mid-level engines, is that their time between overhaul is just about 500 hours. So you can imagine 500 hours with a 10-hour endurance. We are looking at just 50 flights, and you have a major TBO. You have to overhaul majorly the engine. An engine can only be overhauled at least 5 times? I have been told 4 or 5 times. And hence, in the life of an aircraft, an engine is almost like a consumable for a UAV. What have we done? Where are we now as a company? We have got a tie-up with the Sky Power GmbH. It's one of the leading providers of small engines. They provide engines to Boeing. The in-situ, the Scan Eagle uses their core 28cc engine core. We have tied up with them. It's a deep technology transfer and sharing with them. They're the market leaders for EFI 2-stroke air-cooled engines, and they also have a Wankel engine. We have divided our entire program into different phases. The first phase, I'm lucky that my team is highly experienced on UAVs and engines. We were all from Tata's earlier. And we are already providing the integration support for these small UAVs to the Indian companies. There are at least 3 programs which are going on. Next, we are setting up an engine testing facility, which, as I said earlier, is extremely critical for any UAV program in the country. If you don't have your own engine overhaul facility, a testing facility, you're as good as gone. As the phase 3, we'll be sending our engineers to Germany, and they'll be getting trained on manufacturing from a CKD, which will also be equal to the overhaul capability. Next, we are also looking at locally developing. India has a great ecosystem on manufacturing aerospace grade parts, sim tools, Skanda. There are so many parts manufactured in the country. So we'll be manufacturing some of these parts in India and sending them abroad again. Last but the most important is we are trying to come down to one particular engine configuration which will be co-developed by us and Sky Power, and which will be introduced not only to our country but to the entire world. So that's a very critical one that we are looking forward to starting. Just my last thoughts, in an engine of this range, 50% of the value, and actually more than that, is lying in the ECU, electronic fuel injection, and the starter generator. The actual mechanical component of an IC engine, a 2-stroke IC engine used in tactical UAVs, is not so much. It's about 30-40% odd. Our next level of discussion, which is we were just brainstorming in the company, that can the Indian automotive subsystem, the ecosystem, be used to manufacture these or to design these? This is an open question which I don't have an answer to right now, but this is a question that we'll be trying to tackle in the next phase of it. That's all from my side. Thank you.
Thank you, Mr. Vikram Bansal. We wish you all the success, and we wish that there will be many success stories like yours with your colleagues and friends and so many people who are waiting in India. Now I request our Secretary DD&D and Chairman DRDO, Dr. Samir V. Kamath, to come on stage and present the mementos to the speakers, please. First, I invite on stage Deputy Chief of Air Staff, Air Marshal Narmdeshwar Tiwari, AVSM VM, please. Thanks, sir, once again. This will be a memory of you being with us. Now I request Dr. Girish S. Devdhar, DS and DG ADA, to please come on stage, please. Thanks for your guidance, sir. We will remember the moment. Professor Sudarshan Kumar, sir, Head Aerospace Engineering, IIT Bombay. Thank you, sir, once again for your excellent talk. Now, Director Engineering and R&D, HAL, Dr. D.K. Sunil. Please come on dais, sir. Thank you, sir, once again for your enlightening talk. Now I request Shri Alok Nanda, CEO, G India, to please come on stage. Do we have Shri Alok Nanda? Okay, he might have left. If he comes, we will call him again. Now I request our young friend, Shri Vikram Bansal, CEO and founder, Asset Robo. Shri Vikram Bansal. So now I'm right in your title, but I'm sure you will have the doctorate. Wish you all the success. Friends, now we come to the last session. And I request again our Dr. Samir V. Kamath, Secretary DD&D and Chairman DRDO, to chair this session of panel discussion. I invite on stage Deputy Chief of the Air Staff, Air Marshal Narmdeshwar Tiwari, AVSM, VSM, Dr. Tessie Thomas, DS and DG Aero Systems, ACNS Air Materials, Rear Admiral Deepak Bansal, VSM, Dr. S.K. Jha, Chairman cum Managing Director, Midhani, Dr. D.K. Sunil, Director Engineering and R&D, HAL, Dr. Abhay A. Pashlikar, Director CSIR, NAL, Professor Joseph Matthew, Chairman, Department of Aerospace Engineering, ISC Bengaluru, Mr. Michael Paskov, Senior Vice President, Dassault Aviation France, and Shri Ankit Mehta, Co-founder and CEO, Idea Force, to come on the dais for the panel discussion, please. Over to you, Chairman, sir.
So I think we had a very interesting session. Our Honorable Raksha Mantri has also given us some directions in his address to us. I think we are already 45 minutes behind schedule. So I'll request my panel members to start with a minute or two on their thoughts on this topic. And then we'll open up the panel for questions from the audience. So we'll go one by one. and I'll try to moderate as much as possible.
I think the topic itself was very, very relevant. I would say that Aero engine is one area where there is, like the Honorable Raksha Mantri said, that we need to change the status. And the time has come now. I think today, with whatever we learned on the Kaveri program, as well as, you know, what we just heard what HAL is doing, what other private sector industry is doing, I think today we have reached that critical mass where if we have a little push, we should be able to go to the next level. And I'm hopeful because for the Air Force especially, it is very, very important strategically to have this program. We know that other countries are also developing, and some technologies are very critical. It requires a lot of infrastructure development, especially in terms of, you know, autoclaves and other things. Similarly, very important aspect is the HR development, because I think unless we have the right people in this area with the right funding, I think the progress is going to be slow. So that is one area which I think we should focus on in the academia, in our engineering institutes, to get the right kind of practical experience. And for that, I think organizations like GTRE should actually interact with some of these IITs and NITs and other engineering colleges to bring some kind of an exchange so that the practical experience of how to develop an engine starts, that learning starts right from there, and they are able to contribute so that when they pass out, they come with certain experience. And some of these, PhD students or, master students actually get to work in these labs, for short durations as interns, because this is very important to develop this critical mass so that we can take this technology to the next level.
I'll now request Dr. Tessie Thomas.
As everyone mentioned, we need to have the engine on time. The learning curve, what we have got from Kaveri engine, has given us the impetus to take up a derivative of Kaveri engine, which will propel the unmanned compact aircraft. I'm sure the technology has matured in that. That comes only at the 80 kilonewton class. When we look at 110 kilonewton class, we need to take up on the technologies where additive manufacturing, large forgings, titanium forgings, what I'm talking about, size of 800 mm and above. Then we need to look into the single crystal related materials, blades, again damage tolerant. All these new technologies and aerospace grade materials. One is to have the additive manufacturing capability along with digitization, automation, and the thermal management. And engine is again, aero engine is a combination of interaction of aerodynamics, structure, thermal, and all of them put together, it has to function. It's when you see the missile technology, there is a different grade, whereas airborne aero engines, it need one more step ahead. As our defense minister also mentioned, we are putting our effort in making this new category engine to come up within another 10 years time. Some technical gaps what we are having, we are looking forward for collaborative efforts with industry, academia. Academia is giving a lot of input to us with respect to the aero-elastic and unsteady flow. All learning curve from that has been already come, and today we have an ecosystem with the industry as well as the academia, wherein which we'll be able to take up the engine design in a better and a faster way forward. Thank you.
Thank you, sir. At the very outset, I would like to thank Chairman DRDO for giving me this opportunity to be among such a distinguished panel. I am an aircraft maintenance engineer, and while we are looking at the future technologies, I would be very candid to say that I am maintaining a fleet which comprises cutting edge, those be MS-60 Romeos, P8Is, and maybe MiG-29Ks, also obsolete systems. And when the balloon does go up, if it goes up, then I'll be fielding not only 4+ generation aircraft, but also the obsolete aircraft. And my job would be to maintain that obsolete fleet to deliver whatever is intended to do. So in this scenario, the challenge before me, as partly what DCAS also touched upon, is to connect these 7 indigenous aviation elements, take the best out of them to maintain my fleet, whatever is required to do. In that regard, I feel that there are jewels, there are gems of excellence lying scattered across the country. And the challenge before us in the services lies how we can thread these beads. So I would just like to recite 4 lines, and thereafter I would take on the questions as the chairman said so. Full many a gem of purest ray serene, dark unfathomed caves of the ocean bare. Full many a flower is born to blush unseen, and waste its sweetness in the desert air. And this is what is my intent, that this will not let it happen. We need to connect all the dots. Thank you, sir.
Pashilkar, I think you have a mic there.
So firstly, thank you for this opportunity. So I had basically just 3 perspectives to share with you. The first one is I come basically with a background in flight control related technologies, initially with the LCA, and now at NAL we are responsible for spearheading the civil aircraft projects for the country. So from that perspective, from the early perspective of the LCA, I would say we've mastered the platform in terms of aerodynamic structures and so on. We have mastered flight control to a large extent. We now have the radar, or we have the capability to have a radar on board and the weapon systems that go with it. So this aero engine part is perhaps the one which requires now great impetus so that we master that, and then we have that element of strategic autonomy that is so important for us to be able to go forward. So that's point number 1. The second point was, which struck me, was that since the 60s, the jet engine, at least especially in the civilian domain, we have seen 80% improvement. You heard Mr. Alok Nanda talk about the kind of challenges that they are now looking from the LEAP engine toward the RISE engine category, something like 10, 15, 20% kind of jump. So therefore, in context of gas turbine engine, my understanding, we are dealing with a fairly complex system. I think Tazi Thomas mentioned that as well. We are dealing with high temperatures, high pressures, very high RPMs, and all kinds of complex system to then handle the thermal and all those issues which will arise in a rotary turbine machinery of that kind. So therefore, the challenge of actually realizing an engine is not to be underestimated. And the fact that today we are where we are, I think it is commendable that there was presentation from both from HAL and also I heard on 12th how the GTRE has been able to achieve success in this area. So again, to underscore the point, this is a long cycle development. We should not underestimate that. At the same time, I thought that there are technologies today which are enabling these achievements of 15 or 10% improvement, whether it's additive manufacturing or better modeling and simulation capabilities that we have for cascade flows and for ability to use next generation of materials. All of that needs to be looked at very carefully in order for us to go forward. So my thought would be that we need to very carefully decide what is the target that we want to achieve. I'm sure we cannot achieve the state of the art in one big leap. That to me sounds like a very unreasonable task. And therefore we have to be very clear about what is our intermediate goal or the near goal, and then what is the future goal. So that's the second point which I wanted to make. The third one is related to NAL. At NAL, we're typically not so much into the large gas turbines, but more into Wankel engines, IC engines. To some extent, we've also made forays into small gas turbines. My colleagues have developed that. Also a small pulse jet engine. Typically for smaller thrust, we are talking of 2.7 kilonewton. So more in the UAV class rather than the bigger engines. But then again, as a research and development establishment, we are happy to support any activity that is taken up in this country, whether it is for testing, characterizing various components which we are fairly competent to do, and if possible also to kind of assemble smaller engines and support any of the national initiatives. Thank you.
Thank you, Doctor. Dr. Jha, let's hear a materials perspective.
So at the outset, I would like to thank Chairman DRDO for giving this opportunity to talk about the materials. One very good advantage which India has got because of the culmination of R&D and industry together, and that is in fact the example is in Midhani. Right from the beginning, when India decided to go for development of all the platforms, whatever you say, the missile and cavalry engine, everywhere there was emphasis that materials should be developed within the country. And today, because of that, the many materials which we find today, which will be the future requirements for our aero engine or for the present requirement of certain aero engines, what we are developing today, Midhani is meeting all the requirements. And I am sure that today if you go for the higher class of engine also, it is possible to get the material within the house. What we need, that addition of certain infrastructure. If those things are added, it is possible to make all the requirements coming for the aero engine requirements. Either you take in the class of titanium alloys, super alloys, we are developing a lot of cobalt based alloys and castings, forgings, investment casting. So many things have been added, and now recently it was also decided to go for production of the metal powder, because additive manufacturing is the requirements for all the niche technologies in the country. And where the requirement of the aerospace grade powders are the main requirements. So where we are thinking that how we can make the metal powders, since already you are having the alloy making facilities, it is possible to make the metal powder with the very infusion of very less type of effort. And since we have already the technology partner available with us, it is possible to develop. And not only that, in fact, certain equipments of the higher capacity also is being thought of. And in the area of aero engine components also recently, a number of components we have developed along with the DMRL, and those things are already flying in our certain platforms. So which is given us the strength that whatever we develop and produce, it is meeting the requirement of the standard specification. And that is another strength we are having in the form of our certification agencies, because with their strength and their support, it is possible to get a right quality of product into the system.
Thank you, Dr. Jha. Now I request Professor Matthew.
Thank you. The mandate of a research university like the Indian Institute of Science, and indeed at least part of what is required of the IITs and so on, is to conduct research and advance it. These are challenging things to do, but this is our mandate. We do this in two ways, and in both cases there is a deep connect with industry. One is where a professor thinks there's a promising idea and pursues that till something is realized. The other is when industry has a suitable challenge and then that is pursued in academic institutions. In both cases, we go through a sequence of tests to establish systematically that what we are doing is right, that what held the promise is being realized. And and with that in mind, what is the way forward for aero engines? This is something that we think is quite exciting. In fact, we are in this business. Many of us have joined in aerospace engineering because it is exciting and there are significant high performance challenges. What is the way forward? If you stand out there during the flying display and you watch the LCA, everything that you see about it, the maneuvers and so on, all of that is ours. It is built here. But if you hear it, that's not ours. I would like to hear our engine on that. I think that's the next step in the development, in the testing, and I think it's probably ready. And if that is done, then we can go to the next stage, and this will provide, for us, the excitement is the challenges. We have built up a lot of understanding over these years, and we are eager to deploy that in new missions. And I think all this investment in the defense sector for the engine should carry over to civil sector as well, and that's also right. So I think there's a need to develop engines for both, and I think the Kaveri engine needs to fly on the LCA. That's what I want.
Thank you. Mr. Paskov.
Good afternoon. Thank you very much, Chairman, to invite our company to participate to this very distinguished panel of eminent specialists and audience. I would like just maybe to highlight 3 points based on the standpoint of an aircraft manufacturer. Futuristic technology are definitely needed for combat fighter manufacturing because we embed in the limited volume and the very hard environment state-of-the-art technologies related to for the engine, for sure, but the weaponry, the system, the sensors, but also think technology related to the sustainability of the aircraft and also thinking about of the maintenance. We are focusing on the customer need, and there is not a technology that supersedes the others. The first is to define and to develop an aircraft that will fulfill the mission of the customer, and the customer is for us the Air Force or the Navy. The second point related to futuristic technology I would like to highlight is that these are related to the aircraft, to design, produce and so on, but also the technology we are using to design the aircraft, the technology we are using to produce the aircraft, and the technology we are using to maintain. We have technology available now with enhanced reality. We have the digital manufacturing, we have virtual reality, we have the issue of cyber protection of data. An aircraft manufacturer has to take as important, I would say, as the technology to be in the aircraft, in the combat aircraft, the technology we are using in the environment of the aircraft in order to design something that, again, answer our customer main request. And I'm going to the third point. I would say the key, the capability is to be able to make trade-off between systems and technology. There is not a dominant technology for us. The way is to see how we we conceived this product bearing in mind that he has to answer to our customer needs, but also to be aligned with the schedule we have committed on and the cost we are committed for the budgetary constraint of our customer. I will maybe highlight with two examples, everyone will understand. Combat aircraft are really linked to low observation. And when you are speaking of this, you are addressing materials from one side, for sure. We have available a lot of materials to avoid electromagnetic and optic signature. But we have also to address the design of the aircraft, what we call the radar cross-section computation. So our engineers are working always going between materials and design to material and vice versa in order to reach the optimization. The optimization is key for that. I will take another example for which DRDO is working a lot. It's for an aircraft to be operated from an aircraft shipped carrier. Here you are addressing a very sharp environment. You have electromagnetic interaction with the ship. You have to maneuver the aircraft on a very limited surface and volume. You have to ensure the maintenance of the aircraft also in this limited surface and volume. So again, we are facing trade-offs of technologies. There is no dominant technology, but against optimizing. And this is what we consider as a key priorities. And we are, I would say, I'm very honored again that we have the opportunity to share with DRDO part of those technologies and way of designing. Thank you very much.
Thank you, Dr. Paskov. Dr. Sunil.
A couple of thoughts. One taken from what DC has said, that most of us as technologists and designers, we like to do the so-called funda part, the interesting part. But finally, when you talk about an aircraft, it has to fly every day. The support systems need as much emphasis. I think that emphasis lacks, and we tend to do it later in the day. So that's a takeaway. I think it requires as much focus upfront, right, rather than later. It's similar with the engines. I mean, the instrumentation and the maintenance is half the job. The second point is materials is a basic issue in all the engines. Recently, we had an initiative where our Foundry and Forge put together all the agencies, GTRE, Similac, and try to come up with a sort of common compendium of materials. We're using a variety of materials. So I think that kind of collaboration is perhaps will lead to Midhani having a smaller portfolio to produce rather than different. So these are the two takeaways that I feel which are important.
Thank you, Dr. Sunil. And the final word to our young colleague, Ankit.
Hi, sir. Thank you so much for having me on the seminar today. I think while I cannot represent the engine world, but I can probably represent the startup world, and I'll probably start off with a small quote that I really like a lot, which is, the reasonable person adapts himself to the world. The unreasonable one persists in trying to adapt the world to himself. Therefore, all progress depends on the unreasonable man. And I think, the topic particularly of a gas turbine engine calls for an unreasonable effort from everybody involved to realize it in our country to the best possible extent of our dreams and visions. What I am excited to note through this last few years, where unmanned systems have started to take a lot of fore in terms of where the technology is headed, I believe that there will be a need to look at these kind of systems for much smaller platforms, much larger platforms, but not just for manned platforms. And therefore, there is an opportunity for a lot of startups to explore and take that bold step, like we have taken in the space segment, to come up and explore this opportunity as well. Space has exploded quite well in our country, particularly because there is a lot of civil use of the space technology where a lot of outcome is expected. Similarly, in my opinion, aero engines could also take a huge leap on the startup side of the house. The gestation period may be longer because it is not a one-time use system. It has to use and work for a really long period of time. But I believe that certain civil cross-functional uses will really boost the ability to build some of these engines, particularly on the smaller side that can support unmanned systems.
Thank you. So I think we are now open for questions. Yeah, I think. Please identify yourself.
Good evening. I am PC Jain from DRDL, and it's highly enlightening from the panelists that the enabling technologies for the aero engines are all available, whether additive manufacturing, simulation, testing. So my question is to panelists, in the framework of MDO, multidisciplinary optimization, how this particular simulations and in terms of the performance when we do the testing can be clubbed together.
Any of the panelists wants to take this question?
Yeah. As a system, as a total system, system engineering takes the most important part, and your multidisciplinary optimization is one of the branch of it. So this part of all the designs what we take up.
Sudarshan Kumar from IIT Bombay. My question is to both the officers from our forces. You talked about some issues. We have been, or rather my colleagues have been interacting with the various places and so on. In fact, we get many officers from the forces who come for higher studies, they interact, they do say there are many technological challenges, problems. Now, the issue is, it just stops there. We don't know how to proceed further. Like, we have visited many places, NAI, Goa, Kochi, then Karwar, and so on. We have identified half a dozen problems. After that, we don't know where to go. So, this is one part. Another part is academic part, which I have been trying for last 10 years. That RAC comes, which is again a bureaucratic organization, I must say. They come every year, send a letter, how many seats can you offer to our DRDO and armed forces? Every year we say 20, 30 seats we can offer in aerospace department. You know, the letter gets modified and that 30 becomes 3. I don't know what to do. I'm ready to accommodate even 50 officers or 50 scientists from DRDO. I don't know how to take care of this bureaucratic problem, so-called, let me quote RAC.
Well, sir. So I'll catch the bull by the horns then. All right. You are right. I made a mention in my opening, remark that we are trying to engage with 7 indigenous aviation elements. Which are the 7 indigenous aviation elements as per what I think is? First is academia. Then there is ISRO. Then is Aero Cluster Labs. Then we have Air India, erstwhile, it is not privatized now, Permanence Helicopters Limited. Your industry, including the private one. And lastly is, I've forgotten the 7th one. But what I meant to say, there are 7 indigenous aviation elements who are domain experts as far as aviation is concerned. And you're absolutely right that the military does not understand what academia does. When I go to academia, I think you'll give a product to me. It is not like that. In the military, we are supposed to work as of yesterday. We are not supposed to wait and keep waiting, tariq ke baad, tariq ke baad, tariq. It's not possible like that. So you are right. But you see, for that reason is why we are engaging with academia, so that you come and see exactly how we are operating, what is our patience level, what exact. So if you can give me a quick fix and just in time, I think that is the essence. We have made a beginning, and I'm sure your concerns will be addressed within no time at all. The beginning has been made. So that's all I can tell you.
Hi.
Yeah, just let me address address the second question he had. Is Dr. Varaprasad or Sushil Verma here? If they are not there, this is the first time I am hearing that this is a problem. So what I can do is, once I go back to Delhi, I'll find out why this is happening and then get back. Yeah.
Hello.
Yeah, please.
Good evening. My name is Guru Shankar. I'm from a startup company called Deya Technologies. We are working in the domain like Aero engine. We are currently working on the development of micro gas turbine engine. Being a early movers in this specific domain, and first of all, thank you very much for recognizing this as a national importance. And the kind of challenges we are seeing currently is the availability of the ecosystem. If you look at the space, the government has already cultivated the space ecosystem, but when it comes to gas turbine, it is still not there. So whether it is with academics or with the research labs like DRDO labs or with any government funding agencies, we don't see that ecosystem, whether it is in terms of testing or the expertise available. Is there any thought process within DRDO to create a single platform where companies working on this gas turbine domain can reach out to them, utilize the expertise available on the single platform?
So GTRE is our main laboratory which works on gas turbine engines. So they should be your single point contact. You can approach Director GTRE at any point if you have any issues.
Sure. Okay. Thank you very much.
Yeah. Gentleman in the second row.
Sir, I'm a retired Group Captain Narang. I'm from Drone Federation of India and I've been an aviation researcher. Aero engine is a complex system, we all know. But what is missing is, one, amount of funding required. So it's a 1 point. The second part is synergy among stakeholders. And third is, before the engine is delivered, meeting the expectations of users. So unless you meet the users in time, the user buys, let's say, half of the engine, the economic viability or the viability is gone. So three aspects. How do we address in our future plans? Sir? Thank you.
It's a very complex question. I'll request Dr. Siddiqui to answer this. He's the best suited to answer this.
So I will split the question in 3 parts. Like first you spoke about the funding part. Yes, we all know that this technology needs enormous amount of funding. But having said that, as during my keynote talk also what I addressed, with whatever funding what we had in the Kaveri program of $0.5 billion US by any internet means, you can really imagine what kind of a funding what we are talking about. With that funding, whatever status today the country has achieved is something stupendous by any international benchmark standards. Yes, certainly no one looks for more and more funding, and now today we are expanding our horizons and we are talking about going for the 5th generation engines where we are talking upward of $5 billion US or so. Just to give it is not the currency nomination what I am talking about, and that's the way things happen. And also my good friend Mr. Alok Nanda brought out from GE Engines, unducted fans, 30 years for technology maturation. So these things don't just happen in the jiffy. We have to have the willpower, we have to have the risk-taking appetite to invest in these kind of technologies, bring in the best whatever is available in the country. Capabilities are plenty in the country. Capabilities are plenty. How we are going to network those capabilities is what is important at this juncture. If we do it, let me assure you, up to 4th generation engines today, country has got that capability to deliver engines up to 4th generation class. I'm not just talking through the hat, I'm saying with demonstrated capability. Perceived capabilities are different, demonstrated capabilities are different. Demonstrated capability, small turbofan engine. Today, we are able to fly those engines in the cruise vehicles. No mean achievement. Funding, 75 odd crores. So now you can weigh for yourself. We have achieved stupendous things, and there is enormous scope to grow. Basic foundation has been built, so we are there. Also, just to my startup friend, a ecosystem does exist. It is like to get more aware about the ecosystem, what is prevalent in the country. As Chairman DRDO mentioned, you are most welcome to contact GTRE at any point of time in whatever way we can handhold. We will handhold, and we will together work and make it happen.
Thank you, Siddhi.
Yeah, good evening to panel members.
Pretty soon you can stand for elections. Yesterday also you got
Yeah,
Good evening, sir. This is Vinod from IIT Indore. Dr. Jha and some other distinguished person has elaborated on futuristic technology, and we also discussed about ready manpower for our new generation requirement, as well as for this new generation aero engine components development. So in this context, this additive manufacturing is a hot topic, as well as materials will be in our core. So for additive manufacturing, particularly quality powder production will be very, very essential part. And it will be challenging also, because this component requires several types of materials. So not only for the production of those materials, but for maintenance, particularly this repairing section requires a lot of quality powders. So DRDO has established and supported several labs and this funding to 1G IIT. And I request Dr. Kamath to consider this 2G IIT also for their funding, so that we will also able to deliver up to the quality what you are looking for. So I was thinking to somehow put this point in front of you for your kind consideration. Thank you.
We are also looking at second generation IITs. It is not that we are only looking at the first generation IITs. We have opened centers of excellence in IIT Jodhpur, IIT Hyderabad. IIT Indore also is in our radar, so please don't worry about it. And even if the center of excellence has not been opened in IIT Indore, you can take projects from the IIT in which additive manufacturing has been identified as a domain of interest. So IIT Hyderabad is, if I remember correctly, identified as the domain IIT for additive manufacturing. So you can propose whatever projects you want to take in additive manufacturing through that center of excellence.
So, I'm A.T. Sriram from Ramaya University of Applied Sciences. See, my question is very simple question. Like, we are talking about Kaveri derivative engines for other applications. Something similar to it, if you see aero derivative engines, and then we are sure that the technology development we can able to come with the Kaveri engines in soon time. But if you see the history, even GE if you take, their power plant and energy things and the side things that through that they developed a lot of technologies. So in the same sense, the gas turbine engines also used in the ships and all. So I sure that GTRE also helped some of the gas turbine engines in the ships and all. The precise question is that main battlefield tanks, that what we are using is the T-72 type of engines. Is this any plan if you right now if you plan it out with the main battlefield tank itself with the gas turbine engines, will it enable our technology in the future? Is this any direction is there? That's what I hope I convinced my question.
Yeah, I don't think at this point gas turbines are being looked at in tank engines. They are still going to be internal combustion engines. But we are looking at adding turbochargers to these engines to improve their performance.
Yeah, good evening panelists. My name is Ravi. I'm here representing a startup company called Sirinor. I have my colleague Abhijit. We are in the subsonic and supersonic jet engine, what we are trying to build here. We have finished the IISc feasibility study and kind of give us an indication of very positive feedback. What we are really looking at the next step is to how do we really collaborate and work with the right partner in terms of building the test engine case, as well as, of course, funding. We also did a lot of research and found out, unlike in other international countries where, particularly in the US, like Boom and etc., there's a lot of government funding and support is being provided. Because of that, the program is, very rapidly ramping up. So I just probably would like to, get some thoughts from the panelists so we could move forward. And we are aiming anyway next 3 to 5 years to bring this program into rapid conclusion.
So in DRDO, we have a mechanism called Technology Development Fund. So you can approach DRDO headquarters. Mrs. Needi Bansal is here. You can get the details from her on how your programs can be supported through this Technology Development Fund. There is a process, of course. You'll have to follow that process. And if your project gets selected through that process, you will definitely get funding from us. Thank you.
Sure. Thank you, sir.
I think we are already now 25 minutes above schedule. I think we'll wind up this seminar today. I think it has been a very interesting panel discussion, and I hope some of the points which have emerged today, although we don't have the solutions to all the things which were discussed, but what I can say in the end is, though the panel eventually became only about aero engine, though the topic was much broader, I can say that it's a very challenging technology. We have put in a lot of efforts in this country, and as Mr. Siddiqui said, I think we have now reached a point of maturation for 4th generation engines, but what we need for the future is the 5th generation engine, for which I think efforts are on, and I'm sure in the next 10 to 15 years, we will be able to make a 5th generation engine which will power our aircrafts. Thank you.
Thank you. Thank you, Chairman Sir, for chairing the session and all the panelists. Now I request Chairman DRDO to present mementos to the panelists, please. Sir, please come there. First, I request Deputy Chief of Air Staff, Air Marshal Armdeshwar, to come on the dais, please. Next is Dr. Tessie Thomas, DS and DG Aero. ACNS Air Materials, Rear Admiral Deepak Bansal. Please come, sir. Dr. S.K. Jha, Chairman का Managing Director, Medhani. We thank you, sir. Dr. D.K. Sunil, Director, Engineering and R&D, Hindustan Aeronautics Limited. Dr. Abhay A. Pashlikar, Director, CSIR, NAL. Professor Joseph Matthew, Chairman, Department of Aerospace Engineering, ISC Bengaluru. Mr. Michael Peskov, Senior Vice President, Dassault Aviation France. Shri Ankit Mehta, Co-founder and CEO, IdeaForge. Now I request DG Aero, Dr. Tessie Thomas, Madam, to present a memento to our chairman, sir, please. Madam has been guiding force behind the seminar, and she has guided us at every point. And Chairman, sir, has always supported this seminar, and it has gone in the right direction. Now I invite Director CAPS, Dr. Raj Lakshmi to propose vote of thanks. In the meantime, I must apologize to all those who did not get seats or who did not get the proper seats. I apologize also for not giving any breaks and not arranging very high quality level of snacks. I also apologize for anybody I have hurt due to any words or anything I have missed or I have spoken wrongly. With my apologies, I request Director Cabs to propose vote of thanks. And she won't thank herself, and so I must thank her. She has been the guiding force and organizing person behind this seminar from Bengaluru. I only wrote letters to her from Delhi and tied up things in Delhi. She did everything at Bengaluru. Madam, please come and deliver vote of thanks.
On the dais and off the dais, ladies and gentlemen, I will keep it very short because it's already late. As we have now come to the end of the seminar, I take this opportunity to convey my sincere thanks to Department of Defense Production and its officials for providing excellent support, guidance and coordination for conduct of this seminar. Special thanks are due to Commander Gaurav Arora for his proactive support. I thank Secretary DDR&D and Chairman DRDO, DG Aero, DG ADA, DG TM, who have guided us in planning this event. And my special thanks to each for steering the activities to make this event a grand success. I express my gratitude and thank all the speakers, panelists and participants to their valuable inputs and wholehearted participation. I also thank Dr. Narendra Kumar Arya, Secretary ARDB and his team, who worked relentlessly to make this event a success. I also appreciate Dr. Balakrishnan, Cabs and his team, who, while bridging the gap, provided all the support to ARDB to make this again a success. Thanks are also due to Director Public Interface and his team, Director ISB, Director International Cooperation, Director Management Service, Director DESIDOC, and various other directorates of headquarters for their timely support. I would also like to now thank the event management team who worked with clock precision throughout the seminar and ensured the success. Last but not the least, I thank the active participation by the audience. Thank you and Jai Hind.